Hello there and welcome to Sleepumentary. Tonight we are going to drift slowly into a story that begins with a question so strange, so unsettling that it almost feels like it belongs in the pages of a science fiction novel. But this is no invented tale. It is drawn from the skies above us, from data gathered by the finest instruments humanity has built. The question is this: what if the interstellar traveller known as 3 Atlas is not leaving us behind at all? What if that great arc across the heavens, which astronomers so confidently describe as a hyperbolic trajectory, is in fact something else, something more deliberate? Imagine for a moment that what appears to be a comet hurtling through the solar system at impossible speeds is actually a vessel performing a maneuver, a slowing down so subtle our instruments almost miss it. A deceleration designed not by chance but by intention. To understand why this suggestion has captured imaginations, we need to pause and reflect on what a hyperbolic path really means. Every comet and asteroid bound to the Sun traces an ellipse, a loop that holds them in the family of the solar system. But a hyperbolic orbit is different. It is the mark of a visitor from far away, a stranger merely passing through, destined never to return. It is in celestial mechanics the very definition of goodbye. And yet here lies the thought that refuses to go away. What if goodbye is not what's happening at all? This is where the line between sober science and speculative wonder blurs. Astronomers assure us that 3 Atlas is simply another shard of ancient ice and rock flung loose from some forgotten nursery of planets. But others ask, what if that's exactly what an intelligent civilization would want us to believe? If you wish to send an emissary across the galaxy unnoticed, wouldn't you cloak it in the most ordinary disguise possible? A comet, a fragment of ice. From Earth such objects are expected. They pass through, they leave, they pose no threat. To hide among them would be the cleverest camouflage. The mind resists this thought at first. After all, comets have always been symbols of the natural and the eternal. Ancient Chinese records etched their appearances into bamboo slips. Medieval Europeans feared them as omens of plague or kings' deaths. To us today they are relics of planetary birth, frozen archives of the solar system's earliest days. But in the age of satellites and stealth technology, does it seem so absurd to think that another mind far older, far more advanced, might one day play the same trick cloaking a probe in cometary clothing? Before we continue, if this tale keeps you company tonight, leave a like and subscribe, only if it truly feels natural. And now softly tell me, where are you listening from, and what hour has the night brought you? And here perhaps is the unsettling beauty of the question. If 3 Atlas is what astronomers say it is, then it is another gift of knowledge, another reminder that we are not alone in the galaxy, not because of civilizations, but because of the debris they leave behind. If, however, it is something else, if that faint curve is not a farewell, but a slowing down, then our night sky may be less empty than we believed. It is a thought that leaves one both awed and uneasy. Because if it is true, then we may not even know when the decision is made whether this visitor chooses to leave us forever, or to linger silently, a witness hidden among the stars. If you were an advanced civilization, one with the ability to cross not just star systems but epochs of time, how would you send out your watchers? Would you make them bright and obvious, daring the universe to notice? Or would you more wisely let them slip through unnoticed, hiding in plain sight? On Earth, we already know the answer. When nations send their satellites aloft, they do not always announce them with fanfare. During the Cold War, entire constellations of orbiting eyes were camouflaged as innocuous weather platforms. Signals were masked orbits carefully chosen to avoid suspicion. Even today, satellites are sometimes disguised, their true purposes hidden beneath layers of bureaucratic labels. In war and peace alike, deception has always been a companion to survival. Scale that instinct up to a civilization thousands or millions of years older than ours, and the possibilities become staggering. What better disguise could there be than a comet? To astronomers, comets are the most natural of visitors. They pass in front of our telescopes, shed tails of gas and dust, and then depart back into the dark. They draw curiosity, yes, but not alarm. If you wanted to place an observer within another system to study quietly, a comet would be the perfect mask. No telescope would blink twice at it. And this is where 3 Atlas unsettles even cautious minds. For though it behaves largely as a comet should, it also refuses to fit neatly into the mould. Its speed is extraordinary, around 30 kilometers per second. That is faster than any probe humanity has ever launched, faster than Voyager or New Horizons, faster even than the particles whipped around by the sun's gravity. Its chemistry too raised eyebrows. Carbon dioxide detected in unexpected abundance. Unusual outgassing, observed from a distance where most comets sleep frozen and inert, and its trajectory hyperbolic, yes, but precise, almost as if plotted with deliberation rather than chance. Skeptics argue, of course, that this is all coincidence, the strange but natural behavior of a body forged in a distant star nursery. But once the question is planted, it grows. If such an object were an interstellar probe in disguise, how would it look any different? Would it not be fast? Would it not display odd chemistry? Would it not follow a path that seems to our eyes both natural and strangely intentional? The unsettling answer is that we might never know, and perhaps that is the most sophisticated camouflage of all. Paranoia has always been a companion to wonder. The same skies that inspire awe also whisper unease. When we look up and imagine something watching back, the thought carries a familiar chill because it mirrors fears we have carried here on Earth for centuries. During the Cold War, entire populations lived beneath an invisible gaze. People knew that orbiting satellites were overhead tracking troop movements, listening for signals, mapping every surface detail. The idea of being watched was no longer a fable. It was a daily fact of geopolitics, and with that came the gnawing sense of vulnerability. If they can see us, then they can strike us. If they can track us, then they can outthink us. That same logic echoes into the stars if something beyond Earth has the ability to observe us what comes next. Science fiction picked up this thread and wove it into culture. Think of the countless novels and films where alien craft hover silently above cities observing before acting. The drama lies not in the attack, but in the waiting and the sensation of being under an eye that never blinks. We project our terrestrial anxieties into cosmic space. The Cold War spy satellite becomes the alien probe. The hidden submarine becomes the comet that isn't quite what it seems. But why does this resonate so deeply? The answer is psychological as much as historical. Human beings are wired to notice when they're being watched. It is an ancient survival trait our ancestors lived and died by the quickness with which they sensed a predator's gaze. The hairs rising on the back of the neck, the involuntary shiver. These are echoes of instincts older than civilization. So when astronomers suggest even in jest that a comet might not be a comet, those instincts flare. It feels like more than science. It feels like survival whispering across generations. Paranoia under the stars is not just fear of the unknown. It is fear of the known being unmasked as something else. A comet is safe when it is only a comet. But if it is a machine, if it is a watcher, then every comfortable assumption collapses. Suddenly the universe is not silent. Suddenly we are not the only ones looking outward. And as history shows, the realization of being observed has never left humanity calm. So 3 Atlas becomes a mirror, not only of cosmic possibility but of human psychology. It shows us how quickly wonder can slide into suspicion, how easily curiosity bends into fear. And perhaps that is why stories like this linger in the imagination, because they are not really about the stars. They are about us. Paranoia has always been a companion to wonder. The same skies that inspire awe also whisper unease. When we look up and imagine something watching back, the thought carries a familiar chill because it mirrors fears we have carried here on Earth for centuries. During the Cold War, entire populations lived beneath an invisible gaze. People knew that orbiting satellites were overhead tracking troop movements, listening for signals, mapping every surface detail. The idea of being watched was no longer a fable. It was a daily fact of geopolitics. And with that came the gnawing sense of vulnerability. If they can see us, then they can strike us. If they can track us, then they can outthink us. That same logic echoes into the stars if something beyond Earth has the ability to observe us what comes next. Science fiction picked up this thread and wove it into culture. Think of the countless novels and films where alien craft hover silently above cities observing before acting. The drama lies not in the attack but in the waiting, in the sensation of being under an eye that never blinks. We project our terrestrial anxieties into cosmic space. The Cold War spy satellite becomes the alien probe. The hidden submarine becomes the comet that isn't quite what it seems. But why does this resonate so deeply? The answer is psychological as much as historical. Human beings are wired to notice when they're being watched. It is an ancient survival trait our ancestors lived and died by the quickness with which they sensed a predator's gaze. The hairs rising on the back of the neck, the involuntary shiver. These are echoes of instincts older than civilization. So when astronomers suggest, even in jest, that a comet might not be a comet, those instincts flare. It feels like more than science. It feels like survival whispering across generations. Paranoia under the stars is not just fear of the unknown. It is fear of the known being unmasked as something else. A comet is safe when it is only a comet. But if it is a machine, if it's a watcher, then every comfortable assumption collapses. Suddenly the universe is not silent. Suddenly we are not the only ones looking outward. And as history shows, the realization of being observed has never left humanity calm. So 3 Atlas becomes a mirror, not only of cosmic possibility, but of human psychology. It shows us how quickly wonder can slide into suspicion, how easily curiosity bends into fear. And perhaps that is why stories like this linger in the imagination, because they are not really about the stars. They're about us. On the night of July 25, in the high desert of northern Chile, the sky was so clear it looked almost unreal. The Atacama Desert is one of Earth's great natural observatories, its air bone dry, its plateaus rising far above the haze of sea level life. Up there the stars do not twinkle, they burn steady and sharp as though you could reach out and pluck one from the sky. It was beneath this ancient canopy that astronomers working with the Atlas telescope first noticed a point of light that did not quite belong. The telescope was built for vigilance, part of a global network scanning the skies for near-Earth objects, anything that might wander too close for comfort. Most nights yield only routine reports, harmless asteroid space, faint comets, space debris catalogued and filed away, but that evening something in the data stood out. The trajectory was wrong. It wasn't looping around the sun like the others. It wasn't bound at all. At first glance, the object was designated C25, N a simple provisional label in the language of comet hunters. But the numbers attached to it, the velocity, the curve of its orbit told another story. This was no ordinary comet. It was moving too quickly at an angle that marked it as hyperbolic, a visitor from beyond our solar system never to return. Almost immediately it earned a new name, 3 Atlas, the 3 acknowledging its place as the third interstellar object ever confirmed after Oumuamua and Borisov, the Atlas honouring the telescope that had caught it in its net of starlight. For the astronomers who first saw the data streaming in there was a mix of elation and disbelief. Interstellar objects are supposed to be rare, so rare that for centuries we doubted we would ever see one. To catch a third less than a decade after the first felt almost like a cosmic prank. One scientist later admitted, it was like fishing in an ocean and pulling up a bottle from another continent twice in a row. You check again and again to make sure the tide hasn't fooled you. Outside the telescope dome, the desert air was so thin and cold it burned the lungs. Inside the control room glowed with computer monitors, the silence broken only by the soft clicks of keyboards and the occasional sharp intake of breath. For astronomers who had devoted years to routine sky surveys, this was the kind of discovery that rewrote careers. Every pixel of the data was suddenly precious, every observation a chance to glimpse something that had travelled farther and longer than human history itself. And yet threaded through the excitement was a darker undertone. Hyperbolic trajectories mean visitors, yes, but they also mean mysteries. Where had it come from? What forces had flung it across the gulfs of space? And why did it already appear stranger than the 2 interstellar guests before it? In Chile that night, as the stars wheeled over the driest desert on Earth, humanity's gaze caught a new spark, and with it, a new uncertainty. To understand why the discovery of 3 Atlas stirred such unease and wonder, you have to remember the 2 visitors that came before. Our solar system for billions of years seemed an island entire of itself. Everything in our skies, from comets to asteroids, was assumed to be native-born children of the same sun. Then in 2017, something broke that illusion. Astronomers in Hawaii noticed a sliver of light cutting through the solar system on a path too sharp, too swift to be local. They named it Oumuamua Hawaiian for scout or messenger from afar. Its shape was baffling. The object reflected light as if it were a cigar, impossibly long and thin, tumbling end over end. Others argued it was more like a pancake, flat and wide. Its brightness shifted unpredictably as though its surface were polished in ways no comet should be. Then came the strangest twist. It accelerated ever so slightly as it left the sun, but no gas jets, no cometary tale could explain it. For a brief moment, humanity peered at Oumuamua and asked, could this be artificial? Harvard astronomer Avi Loeb went further, suggesting it might be a fragment of alien technology. The world debated. science fiction suddenly felt less like fiction. 2 years later, in 2019, the sky delivered another message to Borisov. This one looked different, less strange, more familiar. A comet pure and simple with a fuzzy coma and a tail that stretched like smoke in the wind. Unlike Oumuamua, Borisov left no mystery of shape or acceleration, but its very existence confirmed the lesson interstellar objects were not theoretical. They were real, and they were out there crossing our neighborhood with quiet regularity. For astronomers, this was electrifying. The odds had seemed astronomical, yet 2 interstellar travelers had passed within just 2 years. Together, these two formed a lineage. Oumuamua was the mystery, the riddle without an answer. Borisov was the reassurance, the textbook comet from another star. And then, a few years later, came 3 Atlas, walking the line between them. Its speed was closer to Borisov's, its hyperbolic path clear. But its chemistry and distant activity hinted at something more, something that stirred the same unease Oumuamua had left behind. It is easy to forget how shocking those earlier discoveries were. In 2017, before Oumuamua, no human being had ever knowingly seen a piece of another star system with their own eyes. Imagine living your whole life believing your house stands alone in the wilderness, only to find a traveller's footprints in the snow outside your door. That was the moment astronomy experienced. The door was open. Visitors were real. And if there had been 2, and now 3, how many more were waiting in the darkness when astronomers first realized that interstellar debris was not just possible but inevitable? The expectation was simple: these would be quiet travelers. Harmless random chunks of ice and rock flung loose from their birth systems in the violent shuffle of planet formation. Imagine the construction site of a newborn solar system, planets coalescing, collisions, scattering fragments outward like sparks from a hammer striking stone. Most of those fragments would drift forever, frozen and silent, wandering through the galaxy without purpose. That was the picture scientists carried in their minds, interstellar visitors as boring rubble, shaped only by physics, their stories already finished. The drama was in their journeys, not in their behavior. If you happened to catch one in your telescope, you'd expect it to resemble any other comet or asteroid. The only clue to its alien origin would be its path and orbit, not tied to our sun, a curve of escape instead of return. And then came 3 Atlas. On paper it fit the profile, a hyperbolic trajectory, a speed that guaranteed it would not stay. But once scientists began measuring its properties, they saw strangeness in the details. Its velocity was astonishing, nearly 100 kilometers per second, faster than any comet catalogued fast enough to cross Earth's orbit in the span of a few days. Its chemistry was not the usual frozen water and dust, but heavy with carbon dioxide, a composition that raised eyebrows and questions about its birthplace. And then there was its activity outgassing, not when it brushed close to the sun, but much farther away at a distance where most comets remain locked in ice. For astronomers used to tidy categories, this was unsettling. Random rubble wasn't supposed to behave this way. These anomalies did not prove anything extraordinary. Of course, comets are quirky and nature often surprises us, but they were enough to keep the whispers alive. If 3 Atlas were purely natural, it was still an oddball. If it was something more, then it had chosen its mask well. Expectation tells us to dismiss such oddities as coincidence. But anomaly has its own gravity. It pulls the imagination in, forcing us to look again at what we thought we knew. And with 3 Atlas, the balance tilted ever so slightly away from the ordinary, and toward the unsettling possibility that not all visitors are what they seem. When scientists traced the path of 3 Atlas backward through the galaxy, they found themselves looking into deep time. Its velocity, its inclination, its chemical fingerprints all pointed to an origin, not in the bright bustling plain of the Milky Way where our sun resides, but in the thick disk, an older and more ancient population of stars. The thick disk is a kind of fossil in motion, a dim halo of orange and red suns, many of them twice as old as our own. While the thin disk where Earth lives is filled with hot blue giants, spiraling arms and nurseries of newborn stars, the thick disk is quieter, more subdued. Its stars are metal poor, meaning they formed in an era before supernovae had seeded the galaxy with the heavier elements required for planets like ours. In other words, the thick disk belongs to a chapter of the Milky Way's story when the universe was younger, rawer, and far less forgiving. And so if 3 Atlas truly comes from this region, then it is likely older than our sun itself, perhaps 5 billion years old. That number rolls easily off the tongue, but pause for a moment to let it settle. 5 billion years ago, Earth was not yet a planet. Our solar system had not taken shape. Life as we understand it did not exist anywhere near here. 3 Atlas may have already been on its journey, before the first oceans formed on Earth, before the first cell divided in the primordial soup. What does it mean to hold such an age in your gaze? Imagine an artifact carved by early humans 40,000 years ago. Imagine the pyramids of Egypt 4.5 millennia old. Now multiply those timescales until they vanish into insignificance beside a comet that may have drifted through the galaxy, since long before mammals, before dinosaurs, before even the continents of our planet looked anything like they do now. Billions of winters and summers have passed as it travelled. Stars were born, burned bright, and died in cataclysmic bursts, and still it moved on untouched. Galaxies brushed past one another, sending waves of gas and light across cosmic distances, and still it drifted. When you stand beneath the night sky and imagine its passage, you're not simply looking at a rock. You are glimpsing a survivor of galactic history, a shard of matter that has borne witness to epochs far beyond human memory. That is the strange gift of 3 Atlas, a reminder that age is not measured in centuries or dynasties, or even in species. It is measured in the long, slow heartbeats of the cosmos. To call it older than the sun is not poetry. It is fact. And that fact alone makes it one of the most extraordinary objects humanity has ever seen. If 3 Atlas truly began its journey billions of years ago, then it has been drifting through a galaxy alive with possibilities. Consider the span of time while it crossed those endless gulfs of dark entire civilizations may have risen, flourished and fallen never known to us, never leaving their names in our histories. On Earth, 4.5 billion years took us from molten rock to Mozart, from chemical storms to cathedrals. Life began as microscopic whispers in shallow seas, then evolved into trilobites crawling across Cambrian floors, into dinosaurs thundering through Jurassic forests, into mammals burrowing and surviving, until one lineage of primates looked up and wondered about the stars. That was our story. Now imagine what stories might have unfolded elsewhere in those same eons while 3 Atlas wandered past. Perhaps it passed a star system where oceans stretched wide and deep, nurturing beings that built coral cities brighter than any skyline on Earth. Perhaps near another sun it drifted by, while intelligent creatures carved philosophy into stone or etched mathematics into crystal tablets, only to vanish when their world grew cold. Civilizations may have blossomed and burned out while this silent traveller continued on unknowing, like a messenger that never stops to listen. There is a melancholy in this thought. 3 Atlas may carry no record of those ancient worlds, only its own frozen chemistry. It does not speak of who it passed or what it saw, yet to consider its age is to consider the scale of possibility. If life could emerge here on Earth in less than 5 billion years, why not elsewhere? If intelligence arose here, could it not have flared like sparks in other corners of the galaxy? Sparks that may already be gone long before we learn to see them. When you look at 3 Atlas, you are not just seeing ice and dust. You are seeing a time capsule older than our oceans, older than the very continents we stand upon. It is a shard of galactic memory drifting through our system, like a whisper from worlds we will never know. To call it a relic is almost too small a word. It is more like a page torn from a book, so vast we can only glimpse a single letter left to wonder what the story might have been. When astronomers say 3 Atlas might be 5 billion years old, the first instinct is to picture a simple rock frozen, silent, unchanged. Yet age can be more than just silence. Age can be a disguise. With so many eons behind it, could this object carry more than ice and dust? Could it hide traces of something once made or once used, scars of an intelligence long vanished? On Earth, we know how deceptive time can be. Consider the Antikythera mechanism pulled from a shipwreck in 1901. For decades it was mistaken as nothing more than corroded bronze. Only with X-rays did scientists realize it was a complex gear-driven computer capable of predicting eclipses and celestial motions, or the Nazca lines of Peru, vast figures etched into desert soil. Early explorers thought them mere paths or markers until seen from above, revealing art on a scale invisible from the ground. In each case, what seemed ordinary was later revealed as extraordinary once our perspective shifted. Now imagine that same challenge multiplied across the cosmos. An interstellar traveller like 3 Atlas, battered by radiation and micrometeorites for billions of years, could easily disguise any trace of artificial shaping. A smooth panel might erode into jagged sand, A pattern of symmetry might fracture into randomness. What would remain after 5 billion years? A relic or only the ghost of one skeptics remind us that such thinking risks seeing intention where there is none. Humans are pattern-seeking creatures. We read faces in clouds, gods in thunder, messages in stars. Still the possibility lingers. If a civilization capable of shaping matter at galactic scales once existed, its remnants might look less like shining machines and more like weathered fossils. To us they would appear as anomalies, a comet active too far from the sun, an asteroid with unusual reflectivity, a trajectory that feels too precise. 3 Atlas then becomes a canvas for speculation. Is it merely a rock, an ancient shard of planetary birth, or is it unknowingly a relic, a piece of machinery or industry so eroded by time that only its strangeness hints at its true origin? The line between rock and relic is thinner than we often admit, blurred not by imagination but by the sheer weight of time. Comets are often called the dirty snowballs of the solar system, chunks of ice and some dust that only wake when warmed by the sun. Typically, a comet stirs to life at around 2 astronomical units, roughly the distance of Mars. Their sunlight has enough strength to boil off water ice, releasing jets of gas and dust that form the ghostly tails we see stretching across the night sky. Beyond that distance, most comets lie dormant, silent wanderers of the dark. But 3 Atlas broke that expectation. Astronomers first noticed a faint haze surrounding it, when it was still more than 3 astronomical units away farther out than the orbit of the asteroid belt, where the sun's warmth is weak and water ice should remain frozen solid. Yet here was an interstellar object already stirring breathing into the void. Its coma, the fuzzy halo of gas and dust, shimmered earlier than it should have. The culprit seemed to be carbon dioxide, a more volatile ice than water, capable of sublimating at colder temperatures. But even that explanation carried unease. Why so much of it? Why so active, so far away? Most comets show their true vigor closer in when heat is abundant. 3 Atlas seemed impatient, like a sleeper roused too soon, exhaling long before its time. This anomaly caught attention not because it was impossible, but because it was unusual. If comets are archives of their birthplaces, then this one's chemistry might whisper of alien conditions of a star system where carbon dioxide was plentiful, or of processes unlike those in our solar system. But speculation crept further still. Some asked, what if the timing was not natural? What if this breath was not the warming of ice, but the activation of something else? Picture a machine that wakes when it crosses a threshold, a program triggered not by sunlight but by distance or angle or cosmic radiation. To us it would look like outgassing, indistinguishable from nature's breath. But behind the veil, could it be a system stirring to life after billions of years asleep? That possibility, however faint, made 3 Atlas's distant breath more than a curiosity. It made it a riddle. As the weeks passed and telescopes continued to study 3 Atlas, the story deepened. The object did not simply release gas and dust in a steady, predictable way. Its chemical signatures evolved. Ratios shifted. Lines in its spectrum brightened and dimmed as if following some hidden timetable. At one moment, carbon dioxide dominated. Later, other volatiles emerged. To the careful eye of spectroscopy, 3 Atlas was not static. It was dynamic, changing, unfolding layer by layer. For a comet, change is not unheard of. As sunlight reaches deeper into the crust, different ices sublimate, producing a cascade of emissions. But in 3 Atlas, the timing raised questions. The activity seemed oddly systematic, as though the object were peeling back stages of itself, rather than simply thawing at random. This is where speculation edged into metaphor. Some astronomers wondered aloud, could this be less like a melting snowball, and more like a program running through steps, the way a machine might move from standby to activation, each phase triggered by conditions it was built to recognize? A rover on Mars, for example, awakens when the sun rises, checks its instruments, and then performs tasks in sequence. To an outsider, its behavior might look like nothing more than patterns of heat and shadow. But to those who know, it is evidence of design. Imagine 3 Atlas in this way, not merely breathing ice into space, but enacting a script. Carbon dioxide first, then perhaps carbon monoxide, then something else as deeper reservoirs awaken. To us, these changes read as chemistry. To another civilization, they might once have been signals, instructions, or stages of operation. Of course, the simpler answer remains most likely natural processes carving complexity from simplicity. Yet the evolving chemistry of 3 Atlas touches a deeper nerve in us. It reminds us of our own habit of building machines that respond to triggers. We program satellites to orient themselves when sensors detect sunlight or to switch modes when reaching certain distances. If we do this with our crude short-lived probes, why could not others have done the same on a grander scale? And so each spectral line, each shift in emission became more than data. It became a whisper of possibility that what we were watching was not just geology but choreography. The sky itself seemed to suggest a rhythm, a pattern hidden behind the ordinary veil of chemistry. One of the oldest lessons in science is that nature is messy. Stars flicker with turbulence, rivers twist unpredictably, comets shed dust in fits and starts. Randomness is part of the universe's handwriting. But what grips the imagination about 3 Atlas is the thought, what if that handwriting began to look too neat? When astronomers examined its emissions, they searched not only for chemistry but for rhythm. Natural outgassing produces bursts often chaotic, driven by fractures in ice or sudden exposure to sunlight. But if those bursts ever repeated with precision every 12 hours, every rotation or impulses that resembled geometric ratios, it would raise an unsettling possibility. Patterns are the currency of intention. Chaos may mimic order now and then, but sustained regularity suggests control. Think of Morse code dots and dashes sent across the void. To an untrained ear it might sound like static, yet to someone who knows it is language. Imagine if 3 Atlas's emissions rose and fell in such a way not perfectly natural, not purely random, but ordered enough to hint at an unseen hand. Even a simple periodic signal could change the narrative from comet to construct. Human history teaches us how hard it is to draw this line. When Johannes Kepler studied planetary motion, he first believed in cosmic harmonies, crystalline spheres and divine geometry. Only later did he uncover the true elliptical orbits order that was natural, not supernatural. In the same way, the line between chaos and design is treacherous. Our minds crave patterns even when none exist. We see constellations in sixtured stars, faces and clouds meaning in noise. Yet this craving is not weakness, it is survival. Recognizing patterns kept our ancestors alive. Footprints meant prey or predator rustling. Grass meant danger or food. In the sky, though, the stakes are different. To mistake chaos for design is to weave myths. To misdesign hiding in chaos could mean overlooking the greatest discovery of our species. So with 3 Atlas, every flare of gas, every spectral shift is more than data. It is a test of perception. Is this merely the random breath of a frozen wanderer? Or could it be just maybe a pulse meant to be seen, a code written in light and chemistry? When news of an interstellar visitor reaches the public, 2 primal questions rise almost immediately. Will it hit us? And if not, what does it want? The fear of collision is easy to understand. Humanity has lived in the shadow of impact since the day we learned that the dinosaurs, creatures who ruled the Earth for over 150 million years, were undone in a single violent strike. Even today, planetary defense programs exist because we know one rock in the wrong place could change everything. When 3 Atlas first appeared, the thought of a billion-year-old projectile slamming into Earth was enough to stir headlines, no matter how carefully astronomers spoke of safety. But beneath the fear of collision lies another subtler anxiety. What if it isn't a rock at all? A natural comet is frightening only in its trajectory. But if 3 Atlas were something more, something guided, something sent, then its presence might not be measured in kilometers per second, but in intention. Would it be an emissary, a scout, a probe designed to watch and learn? Or would it be something more ominous, the first bead of a string yet to follow? Here our own history haunts us, for when strangers have arrived on new shores on Earth, the record is rarely clean. Columbus did not bring only curiosity to the Americas. Cook's ships carried not only exploration but empire. To those on the receiving end, a sail on the horizon often meant the end of a way of life. And so when we imagine an interstellar visitor, our imagination leans heavily on the darker side of our past. We know what it is to greet strangers, and we know the cost of being greeted. It is worth pausing, though, to separate fear from fact. 3 Atlas's velocity makes collision impossible. It is moving far too fast to be captured by the sun's gravity or bent into Earth's path. Its closest approach carries no danger. But the human mind is not satisfied with calculations alone. We are storytellers, and stories often speak louder than numbers. The idea of contact, friendly or hostile, echoes deeper than the reassurance of orbital mechanics. So in the silence of the night sky, 3 Atlas became more than an object. To some, it was a mirror of dread collision or conquest. To to others a mirror of hope. Perhaps we are not alone, perhaps we are finally seen. The truth, as always, may be far quieter than either extreme. But fear has a way of filling the gaps in knowledge, and with visitors from the stars, those gaps are vast. 3 Atlas races through the solar system at nearly 30 kilometers per second. To put that into human scale, imagine standing on Earth's surface and watching the horizon. In less than a minute, this object could cover the distance from New York to Los Angeles. It moves faster than our minds can easily picture a blur stitched into the fabric of space. This velocity is the very reason astronomers quickly assured the public there is no risk of collision. At such speeds, no planet, not even the Sun itself, has the gravitational pull to capture it. Earth's escape velocity, the speed needed to leave our world forever, is a mere 11 kilometers per second. Jupiter. The great giant can hold on to moons and comets with an escape speed of 60 kilometers per second. Even the Sun, whose gravity anchors the entire solar system, demands just over 600 kilometers per second to escape. 3 Atlas is not bound. It came in on a hyperbolic path and it will leave on one. The laws of physics leave no ambiguity. This is a flyby, not a strike. And yet that speed invites awe. Humanity's fastest spacecraft, the Parker. Solar probe launched with the help of repeated slingshots around Venus has reached just under 200 kilometers per second relative to the Sun at its closest swoop. But even so, Parker is an engineered marvel designed for a single purpose. 3 Atlas achieves its incredible pace naturally, the product of deep time and galactic scattering, as if the universe itself had given it a running start. There is a strange comfort in this. The very thing that makes 3 Atlas so alien to our experience, its raw, untouchable velocity, is what ensures our safety. Like a stone skipping across a pond, it will pass through, touch our awareness briefly, and then vanish back into the dark, untethered and unstoppable. Still the comparison lingers. Our rockets strain, burn and fall away just to reach Earth's orbit. We marvel when a probe escapes the solar system after decades of careful planning, and yet here drifts a fragment from the stars indifferent to our effort, already travelling at speeds our machines can only dream of. 3 Atlas reminds us not only of our safety but of our smallness. In the language of the cosmos, velocity is history written in motion, and this object carries a story billions of years long, one we have barely begun to read. When 3 Atlas first made headlines, the media followed a script as old as starlight fear, first wonder, second. Articles led with the drama of an interstellar object racing through our solar system, playing on the unease of the unknown. Alien visitor, cosmic intruder, third object from the stars. Headlines glowed brighter than the comet itself, their purpose not to inform but to hook. This is hardly new. In 1910, when Halley's Comet returned, newspapers breathlessly reported that its tail contained cyanogen gas, a toxin. Though astronomers assured the public that the gas was too diffuse to harm Earth, panic spread. Gas masks were sold. Some people sealed themselves indoors. The comet became not a wonder but a phantom threat. The same cycle played out in the mid-20th century during waves of UFO sightings, when the night sky seemed full of unknowns and every light was interpreted as an omen. 3 Atlas slipped easily into that lineage. At first, commentators whispered about impact risks even though astronomers had ruled them out almost immediately. Then came speculation about alien probes fed by social media snippets stripped of context. Fear thrives in the absence of detail, and for a few days the object was framed less as a scientific opportunity than as a cosmic threat. But reassurance followed, as it always does. Scientists explained that its path was safe, its hyperbolic trajectory a one-way passage. Observatories released data images and calm statements. Journalists shifted tone, celebrating the discovery as a marvel rather than a menace. The public story evolved from alarm to awe, from will it hit us to what can we learn from it? This balance of fear and wonder is part of humanity's relationship with the skies. We are unsettled by the unfamiliar, but just as quickly captivated by it. A comet can be both a death omen and a celestial guest depending on how the story is told. With 3 Atlas, the pattern repeated, panic burned fast and bright, then faded, leaving behind a quieter curiosity. In that shift lies something essential. Fear makes us look up. Wonder makes us keep looking. And so the object remained in the public imagination, not as a herald of disaster, but as a reminder of how small and how curious we still are beneath the stars. Once 3 Atlas was confirmed as interstellar, The call went out across the world point, every eye, every lens, every mirror toward it. The Hubble Space Telescope, still circling silently above Earth, after decades of service, trained its aging but precise gaze on the visitor. The James Webb Space Telescope, new and powerful, unfolded its gold-plated mirrors to catch the faintest photons. Together they formed a bridge between generations of science the elder and the prodigy watching the same fragment of galactic history. Hubble's instruments gave us sharp optical images, the faint glow of the coma, the subtle brightness variations that betrayed jets of gas escaping into the void. Webb's infrared eyes dug deeper, reading the chemical fingerprints of those emissions. Every line in the spectrum was like a clue telling us what ices lay hidden in the object's crust, what molecules were freed as it stirred to life. But these telescopes were not alone. Ground-based observatories across the world joined in. From Chile to Hawaii, from South Africa to the Canary Islands, astronomers adjusted schedules, nudged aside other projects, and aligned their instruments toward the streak of light cutting through the dark. What might have been a quiet season of routine measurements became an international vigil. Behind the scenes, the work was relentless. Astronomers lived by the night, and many found themselves camped in control rooms, eyes ringed with fatigue fueled by bad coffee and bursts of adrenaline. Data poured in, images, spectra, timing logs, and teams passed them like relay runners, sharing across time zones, so that analysis never slept. A researcher in Europe might fall into bed at dawn only for a colleague in California to pick up the thread and carry it forward. Coordination like this is a kind of choreography. Slack channels, Zoom calls, and shared archives became the stage where dozens of voices across languages worked in harmony. There was urgency. 3 Atlas was fast, and each night it grew fainter as it sped away. Every observation was precious, like gathering sand from a tide that would soon be gone. For all the cutting-edge machinery, there was also something ancient in the act. Humans have always kept vigils under the night sky, priests watching for omens, sailors steering by stars, shepherds marking the rise of constellations. The astronomers of 2005 were heirs to that tradition. They too kept watch, though their eyes were aided by gold mirrors and CCD detectors. They too whispered questions into the silence, hoping the heavens would answer. And in their quiet persistence, a truth emerged. Even in an age of doubt, humanity is still capable of uniting around wonder. For a fleeting moment, scientists across continents spoke a single language, the language of curiosity brought together by a stranger from the stars. In every great scientific drama, there are those who stay within the guardrails of consensus, and those who lean over the edge, peering into the abyss of possibility. For interstellar objects, one name has become almost synonymous with descent: Avi Loeb. Loeb, a Harvard astrophysicist, stepped boldly into controversy after the 2017 discovery of Oumuamua. While most researchers cautiously described it as a peculiar shard of rock or ice, Loeb argued it might be something far stranger, a fragment of alien technology, perhaps even a discarded probe. His claim drew both fascination and criticism. To many it felt reckless, a leap too far ahead of the evidence. To others it was refreshing, the kind of intellectual courage that science sometimes needs, a refusal to dismiss the extraordinary simply because it is uncomfortable. The debate over Oumuamua revealed more than just differences in interpretation. It exposed a tension within science itself. On one side lies conservatism, the discipline of skepticism, the refusal to entertain conclusions without overwhelming proof. This is science's strength, the reason it has built knowledge steadily, brick by brick. On the other side lies imagination, the willingness to ask, but what if? The courage to risk ridicule by exploring questions that might seem naive, but which, if answered, could redefine our place in the cosmos. Loeb occupied that second camp. His papers and public talks insisted that we take the possibility seriously, even if it made colleagues uncomfortable. Critics accused him of chasing headlines. Admirers praised him for breaking the silence around a subject most whispered about only in private. Whatever one thought, he forced the conversation into the open. And so when 3 Atlas appeared in 2012, it was inevitable that Loeb's voice would rise again. He pointed out its unusual activity, its chemical oddities, its sheer strangeness, and reminded the world that dismissing anomalies too quickly might blind us to discovery. The response was familiar. Some rolled their eyes, others leaned closer. What mattered less than whether Loeb was right or wrong was the role he played. He embodied the tension between caution and curiosity, between the walls that protect science and the doors that open it wider, Without the skeptics, we risk fooling ourselves. Without the dreamers, we risk missing what truly lies beyond. 3 Atlas then became another stage for this old drama: conservatism versus imagination, discipline versus daring. And as humanity watched, the debate was not just about a comet. It was about how we choose to face the unknown safely within the bounds of what we know, or bravely at the edge of what we do not. Before 3 Atlas, there was Oumuamua, the first interstellar guest we ever confirmed, and perhaps the most confounding. Discovered in 2017 by astronomers in Hawaii, it streaked into our system like a messenger from the stars, and almost immediately it defied our expectations. Its brightness flickered as it tumbled, suggesting a bizarre shape, perhaps cigar-like, impossibly long and narrow, or perhaps flat like a cosmic pancake. It lacked the fuzzy coma of a comet, the hallmark of outgassing. And then came the strangest twist. As it moved away from the sun, it accelerated slightly, drifting off course in a way that gravity alone could not explain. For months, scientists wrestled with the anomaly. Was Oumuamua a rock, a comet, or something in between? The absence of visible gas jets made the acceleration puzzling. Theories piled up, some whispered of alien sails propelled by starlight. Others imagined it as a shard of shattered planet, a fragment of frozen hydrogen, or even a nitrogen iceberg, like a relic from Pluto's twin. The public seized on the mystery. The name itself, Oumuamua, meaning scout or messenger in Hawaiian, fed imaginations. Avi Loeb's bold suggestion that it might be artificial poured fuel on the fire. For a time it felt as though humanity stood at the threshold of cosmic revelation, perhaps at last proof of intelligence beyond Earth. But science has its own rhythms, slower and less dramatic than headlines. Careful studies continued. Models grew more sophisticated, and eventually researchers found that Oumuamua's gentle acceleration could be explained by outgassing. After all, gas jets too faint to produce a visible tail, yet strong enough to nudge the object. The simplest answer, as it so often does, proved the most likely. The extraordinary story settled into the ordinary, though the fascination lingered. This is the lesson that scientists carried forward: anomalies invite wonder, but wonder must be tethered to evidence. To leap too quickly toward extraordinary explanations risks not only credibility but also clarity. Oumuamua reminded us that the universe is full of surprises, and sometimes those surprises are natural, not intentional. And so when 3 Atlas appeared with its own oddities, its early activity, its strange chemistry, its speed, astronomers remembered Oumuamua's caution. Look closely, they said. Ask bold questions, yes, but do not forget that nature in all its complexity often writes the strangest stories of all. Science is built on the assumption that given enough time and data, every mystery will bend toward explanation. Oumuamua seemed alien until outgassing made sense of it. Borisov looked strange until it was recognized as just another comet, though born under another star. But what if one day the story doesn't resolve so neatly? What if the data refuses to fit any natural mold? Imagine the months pass and the world's telescopes continue watching 3 Atlas. Spectra are gathered, trajectories mapped, brightness measured. And still the numbers won't settle. The activity doesn't match chemistry. The outgassing occurs at the wrong times. The acceleration, if any, is too precise, too deliberate. The models break one after another. At some point, astronomers are forced to confront the unthinkable. Perhaps this object is not entirely natural. History offers parallels. For centuries, astronomers believed the orbits of planets were perfect circles in keeping with celestial harmony. The evidence disagreed. Only when Kepler dared to draw ellipses breaking from sacred tradition did the solar system finally make sense. In the 19th century, small discrepancies in Uranus's orbit could not be reconciled until Neptune was discovered hidden in the night where mathematics had predicted it. In the early 20th century, the orbit of Mercury deviated ever so slightly from Newton's laws, and for decades scientists blamed a hypothetical planet called Vulcan. Only Einstein's theory of relativity explained it, revolutionizing physics forever. In each case, the anomaly was not an error to be ignored, but a doorway. Behind the stubborn data lay an entirely new understanding of the cosmos. So what if 3 Atlas became that doorway? What if for the first time we faced evidence that resisted every natural explanation, patterns too sharp to be chaos, chemistry too deliberate to be coincidence, motions too precise to be random? The thought lingers like a whisper. How would science respond if the universe at last forced us to admit we were not alone? It has not happened yet. Perhaps it never will. but imagining the possibility reveals something about us. Anomalies test not only our equations, but our courage. Do we cling to what we know or dare to step into the unknown? Every revolution in science began with that choice. Perhaps someday 3 Atlas or another visitor like it will force us to make it again. Imagine the night sky alive with a faint pulse so subtle it looks like noise at first. A regular tick in the data, a rhythm stitched into the background static. That is how it might begin if 3 Atlas were not just drifting but speaking. Astronomers already listen. Radio telescopes sweep the skies constantly gathering rivers of data. In those streams, a pulse from 3 Atlas would appear as a whisper, buried among quasar satellites and the endless hum of the cosmos. The question is not whether it could be detected, but whether we would recognize it for what it was. A signal too faint, too brief might be dismissed as interference. A coded transmission might look indistinguishable from random noise unless we knew the key. And what if the object made a correction shift in course against the flow of gravity that would be harder to miss? Natural comets can accelerate, yes, pushed by jets of sublimating gas. But if 3 Atlas veered in ways too precise, following arcs instead of drifts, the calculations would scream of intention. Telescopes would track the deviation night after night until the truth became undeniable. This was not a stone obeying physics, but a vessel obeying commands. Yet even then, certainty would be elusive. The universe is full of masquerades. A signal could be the echo of a pulsar. A course correction could mimic an unlikely outburst of gas. Humanity's instruments are sharp, but our interpretations are fragile. To notice the extraordinary, we must first believe it is possible. Otherwise, we risk overlooking it in plain sight. And so the thought lingers. What if 3 Atlas has already spoken, already, nudged, already sent its signal into the void and we failed to notice? What if lost among terabytes of data, the first proof that we are not alone, already sits forgotten on a hard drive waiting for someone with sharper eyes or braver imagination to recognize it? At the heart of the mystery lies a simple question. Is 3 Atlas merely drifting, or is it being guided? The difference seems subtle, but in truth it is everything. A natural comet behaves like a feather in the wind. Its path is shaped by invisible currents, gravity radiation, outgassing all forces external to itself. It tumbles without preference, its motion a story written by chance encounters with heat and light. Small nudges accumulate a jet of sublimating ice here, a fragment breaking off there. The result is a trajectory with tiny imperfections like a feather, caught in shifting gusts, never quite steady, never quite predictable. But guidance true control looks very different. It is the difference between a feather and a ship. A ship, though, buffeted by waves and weather charts a course. Its rudder and sails impose intention upon chaos steering toward a harbour, even when the sea resists. Precision emerges where randomness should reign. The wake it leaves is not chance but choice. If 3 Atlas were guided, astronomers would expect to see motions too clean, too deliberate. Its trajectory would not wander, but adjust subtle course corrections aligning it with unseen goals. Perhaps it would maintain a stable orientation for months, or respond to conditions in ways that seemed anticipatory rather than reactive. Patterns like these would whisper of intelligence behind the veil of chemistry, and yet even with the best instruments, distinguishing one from the other is treacherous. A feather might briefly look like a ship if caught in an unusually steady gust. A comet might mimic intention with coincidental jets. Our models are strong, but they are not infallible. This is the razor's edge where astronomy meets imagination. Drift is the assumption. Guidance is the dream or the nightmare. To call something guided is to claim we are not alone in the universe. To call it drifting is to admit that nature in all its messiness still has more surprises than we can count. For now, 3 Atlas remains a feather, but the question hangs in the night air unsettled. What if just once the feather turns into a ship? If the day ever comes when 3 Atlas shows signs of intention, be it a pulse of signals, a deliberate change in course, or some other undeniable anomaly, the world will not simply shrug. The response would be immediate, coordinated, and fraught with tension. Extraordinary claims demand extraordinary care. The first step would be verification. No single observatory, no single nation could shoulder the burden of such a discovery. Independent telescopes would be asked to confirm the data. Panels of experts, astronomers, physicists, engineers would be convened likely under the auspices of the International Astronomical Union or national space agencies. Their job would not only be to examine the evidence, but also to present it in a way that avoids chaos. For chaos is the real danger. History shows us how quickly the unfamiliar can ignite panic. In 1938, Orson Welles' radio broadcast of the War of the Worlds convinced thousands that an alien invasion had begun. People fled their homes, clogged highways, and braced for disaster, all from a piece of fiction framed as fact. Decades later, during the COVID-19 pandemic, we saw again how fragile the boundary is between truth and rumor. Misinformation spread faster than the virus itself, reshaping behavior, dividing communities, eroding trust. An interstellar visitor, if suspected of intelligence, would test that fragility like nothing before. Social media would explode with speculation, apocalypse prophecies, conspiracy theories, hoaxes. Governments would face pressure to reveal everything, while also fearing the destabilization of markets, religions, and political order. Some would call for secrecy, others for radical transparency. Protocols exist in science for announcing discoveries, but they were not built for this. Normally, a new comet or exoplanet is shared in a journal, confirmed by peers, and slowly absorbed into textbooks. But the confirmation of a deliberate interstellar probe would not be treated as a scientific curiosity. It would be a global event rivaling the moon landing, perhaps surpassing it. The stakes are nothing less than how humanity sees itself. And so when the world listens, the question becomes, what story will we tell? Will it be a calm briefing by sober scientists carefully explaining data, or will it be a storm of rumor before truth has a chance to catch up? The answer may depend less on telescopes than on us, our ability to stay steady when the universe hands us news that rewrites what it means to be human. Whenever whispers of alien technology arise, whether from Oumuamua, from radio signals, or from an interstellar visitor like 3 Atlas, another shadow slips into the conversation, the great filter. It is one of the most unsettling ideas in modern thought, born from a simple haunting question. The universe is vast. Our galaxy alone holds hundreds of billions of stars, many with planets. Statistically, life should not just be possible, it should be abundant. And yet when we lift our radio dishes to the sky, when we scan with telescopes and satellites, we find silence. This is the Fermi paradox. If life is common, where is everyone? The great filter is one proposed answer. It suggests that somewhere along the path from chemistry to intelligence to civilization, there is a wall, a stage that almost no one survives. Maybe life rarely begins, maybe intelligence rarely evolves. Or maybe civilizations bloom but then collapse through war, through climate, through exhaustion, before they ever spread among the stars. The silence we hear may not be emptiness, it may be graveyards. Civilizations might have risen and fallen long before we were here to listen. Or perhaps the filter lies ahead of us, not behind an obstacle we have yet to face, one we might not survive. This is why each strange interstellar visitor captures more than scientific attention. It brushes against that fear. If 3 Atlas turned out to be a probe, it would shatter the paradox, proving that someone somewhere made it through the filter. That knowledge would be electrifying and terrifying. Electrifying because we would no longer be alone. Terrifying because it would force us to ask if they survived. Why are they silent now? What became of them? Humanity's fear of silence is as much psychological as scientific. Silence in a dark house makes us uneasy. Silence across the galaxy makes us wonder if we are the last, or if we are only waiting for our turn to vanish. The great filter is not just an equation, it is a mirror held up to our own fragility. And so when 3 Atlas drifts across our skies, the shadow of the filter drifts with it. In its glow we see both hope and dread. Hope that we are not unique, dread that we are not destined to endure. To imagine 3 Atlas as a probe is to imagine engineering so far beyond us that it feels almost like magic. Yet even magic has rules, and if a civilization truly meant to send something across billions of years and light years, those rules would be brutal. First comes energy. Voyager 1. Humanity's farthest emissary left Earth in 1977 and now drifts through interstellar space. Its nuclear batteries are fading after less than 50 years. By the middle of the century, it will fall silent forever. New Horizons, which gave us our first close look at Pluto, carries a similar heart of plutonium fuel good for only decades. Our proudest machines cannot last a century, let alone a billion years. For 3 Atlas to endure such a journey, it would need a power source as steady as a star's heartbeat, or a way to sleep almost endlessly, awakening only when conditions demand. Then comes durability. Radiation in the galaxy is merciless. High-energy particles stream through space capable of tearing apart delicate circuits. Micrometeorites, grains of dust no larger than sand, strike with the force of bullets at interstellar speeds. Our spacecraft, thin-skinned and fragile, would be shredded long before they crossed a fraction of the distances 3 atlases traveled. A billion-year probe would need armor we can scarcely imagine, perhaps self-healing materials or hulls made of elements resistant to cosmic decay. And then there is the sheer vastness of time. Over billions of years, stars themselves shift across the galaxy. The Milky Way rotates arms of gas coil and stretch. The universe itself expands. For a probe to stay coherent through all that, it would need not only strength, but patience on a scale almost beyond comprehension. Even the simplest design, say a passive messenger, faces the problem of erosion. A metal surface would corrode under cosmic radiation. A signal beacon would fall silent long before it reached another star. In 1 billion years, our Voyager disks will be dust, their golden records worn smooth by the endless tide of interstellar grains. This is why most scientists dismiss the notion. The barriers are colossal, the demands extreme, and yet when we think of how far we have come in a mere century, from horse-drawn carriages to nuclear engines, from telescopes of glass to space observatories unfolding in orbit, it is difficult to say what a civilization millions of years older than ours could or could not achieve. If 3 Atlas were such a probe, it would be a monument to endurance, a vessel that laughed at time itself. For now, our Voyagers sail less than a heartbeat into the void. But to imagine more is to glimpse what might be possible if only humanity survives long enough to try. When we imagine 3 Atlas as a billion-year probe, we are really imagining ourselves in the mirror of time. Could humanity ever build such a thing? Could we send a machine to wander through the galaxy long after our cities have crumbled, long after our languages have vanished? To ask that question is to confront the fragility of our own story. Right now, our greatest threat is not the void of space. It is ourselves. We know how to split the atom, but we also know how easily those discoveries can erase us. Nuclear arsenals built in decades of fear still wait like coiled serpents, ready to strike at a moment's madness. Climate change, so sure but no less dangerous, creeps forward with rising seas, failing harvests and shifting storms. These are our filters, the barriers we must pass if we hope to imagine a future at all. To think about alien probes that survive billions of years is to think about civilizations that solved their survival puzzles. A species that endures long enough to master interstellar engineering must have learned to master itself, to survive war, to balance with its planet, to outlast the temptations of destruction. If 3 Atlas were such a probe, it would not just be evidence of technology, it would be evidence of wisdom. And that is where the mirror cuts deep. Humanity is brilliant at invention, but clumsy at endurance. Our machines outpace our politics. Our knowledge grows faster than our wisdom. We dream of colonizing Mars, yet struggle to protect the only world that sustains us. We launch probes into the dark, but cannot guarantee our own survival into the next century, let alone the next billion years. So the lesson of 3 Atlas, whether comet or construct, is one of humility. To survive as long as this object has wandered would mean living in harmony with forces larger than ourselves. It would mean choosing stability over conquest, patience over panic, foresight over fear. Every time we look at it streaking silently across the night sky, we should not only ask what it is, we should ask who we want to become, because if we cannot endure our own self-made storms, the question of probes and civilizations will remain forever hypothetical. But if we do endure, if we learn to pass our own filters, then perhaps someday, long after we are gone, one of our own creations will cross another star system, and some distant mind will look up and ask, as we do now, was this only a rock, or was it a relic? For all the speculation, for all the whispers of probes and signals, the truth is sobering in its simplicity. There is no evidence so far that 3 Atlas is anything but natural. Every spectrum, every image, every careful measurement points to the same conclusion, that this is another shard of frozen chemistry, an interstellar comet with quirks that spark curiosity but not proof of intention. This consensus is not dismissal, it is discipline. Astronomers live by the razor edge between wonder and evidence. It is tempting to leap toward extraordinary claims, but science demands patience. The faint traces of carbon dioxide in its coma, the unusual distance at which it became active, the sheer speed of its passage, all of these can be explained by natural models. They may be unusual, yes, but unusual does not mean artificial. Still, humility is essential. Our instruments, for all their power, remain limited. Even Webb's golden mirrors and Hubble's sharp eyes cannot resolve every detail of a rock racing hundreds of millions of kilometers away. What we call natural explanations are models, educated guesses built from fragments of light. They may be right, or they may be only part of the story. This is the paradox of discovery. We see enough to provoke wonder, but not enough to silence doubt. Oumuamua taught us that anomalies can shrink under the weight of new data, that what looks like design may dissolve into physics. And yet anomalies also remind us how much we do not know. For now, the safe conclusion is the cautious one. 3 Atlas is natural. That conclusion keeps us grounded, protects science from sliding into myth. But humility also requires us to admit that we could be wrong, not because evidence points elsewhere, but because the universe has a habit of surprising us when we least expect it. So we watch, we measure, and we remind ourselves absence of proof is not proof of absence. But until the data shifts, the comet remains a comet and the relic remains only a dream. If one day humanity is faced with an interstellar visitor that truly is not natural, how would we know? The key lies in the difference between randomness and control. Comets, asteroids, and icy fragments behave like drifters buffeted by sunlight, outgassing jets, and the subtle pull of gravity. Their paths bend and wobble in ways that can be modelled but never perfectly predicted. A spacecraft, on the other hand, reveals its artificiality through precision. Consider a comet as it nears the sun, trapped ice sublimates, and bursts through cracks in the surface. These jets act like tiny thrusters pushing the object in irregular ways. The acceleration is real, but it is uneven, unpredictable, and often changes as new fissures open or old ones seal. It is noise written into the language of motion. Now compare that with the maneuvers of a spacecraft. When Voyager 2 passed Neptune in 1989, its course change was exact, planned to the decimal. Its trajectory bent in a way no random gas jet could mimic, sending it cleanly toward the edge of the solar system. New Horizons did the same at Pluto, adjusting its orientation by firing thrusters in timed bursts. The difference is unmistakable. Comets stumble, spacecraft steer. Astronomers use mathematics to tease out this difference. Natural accelerations scatter across a curve, forcing models to adapt with guesswork. Controlled accelerations, by contrast, fall into patterns too precise to be random, consistent thrusts, smooth arcs, deliberate course changes. It is the difference between a feather blown by wind and a plane banking into a runway approach. If 3 Atlas were ever to show a sustained deviation that fit no natural model, a curve too clean, a turn too sharp, it would ignite global debate. Was it coincidence or command? Scientists would recheck every model: solar radiation, gravitational tugs, even exotic ices like carbon monoxide. Only when all were exhausted would the spectre of guidance enter the room. For now, no such precision has been found. 3 Atlas stumbles as a comet should its anomalies within the bounds of nature's chaos. But the principle remains: if one day the sky delivers something guided, we will know it not by what it looks like, but by how it moves. Among the most provocative speculations is the notion that interstellar objects like 3 Atlas might not simply be watchers, but carriers, seed ships drifting across the galaxy with a mission far older than any we can imagine. What if embedded within their icy shells they bore the ingredients of life, or even life itself, waiting for the right conditions to awaken? The idea is not entirely fantasy. Scientists have long entertained the concept of panspermia, the possibility that life spreads between worlds on comets, asteroids, or even dust grains. Microbes shielded within rock or ice could survive the brutal cold of interstellar space, hibernating for millennia, until they feel they crash into a hospitable world. Experiments have shown that certain hardy organisms on Earth, like tardigrades, can endure the vacuum, radiation, and temperature extremes of space. If they can survive, perhaps life could leap from planet to planet, star to star. Cultures throughout history have echoed this theme in myth. Ancient Greeks told of Prometheus, who carried fire from the heavens to ignite human civilization. Hindu traditions speak of the cosmic egg, a seed of existence floating in the void, splitting to give birth to the universe. Even in modern science fiction, from Arthur C. Clarke's monoliths to films like Prometheus, the idea of life being seeded across the stars endures as both mystery and metaphor. Seen through this lens, 3 Atlas could be imagined as more than a relic. It could be a vessel. Not necessarily a machine in the way we think of spacecraft, but a natural or engineered ark, a frozen seed bank launched from some distant cradle of life entrusted to the galaxy's currents. After billions of years, it drifts into our solar system, a potential gift, or simply a reminder that life does not belong only to us. Of course, the scientific hurdles are immense. Cosmic radiation would sterilize most biology over such timescales. Survival across billions of years feels nearly impossible. Yet speculation persists because the symbolism resonates. If we, a fragile species from a fragile planet, already dream of sending capsules into space carrying DNA messages and music, why should we imagine ourselves the first to do so? Whether natural or deliberate, the seed ship idea is less about certainty than about perspective. It suggests that life might not be a solitary spark, but a flame carried from one torch to another across the universe. And if 3 Atlas is merely a comet, then perhaps comets themselves are the gardeners of the cosmos, scattering the raw ingredients of life wherever gravity allows them to fall. As enticing as the seed ship idea may be, the cosmos is not kind to such dreams. Space is an environment that grinds away at every fragile hope, and its cruelty is measured not in years, but in eons. Radiation, time, and decay form a trinity of obstacles so immense that even imagining survival across billions of years strains the imagination. Radiation is the first destroyer. The galaxy is filled with high-energy particles, cosmic rays that slice through matter like invisible blades. They tear apart molecules, shatter DNA, and disrupt the delicate chemistry on which life depends. A microbe sealed within rock or ice might endure for thousands, even millions of years. But billions? Over such spans, the damage would accumulate relentlessly, leaving only fragments of what once was. Time itself is another enemy. Consider how quickly our own creations decay. Satellites in low Earth orbit burn up within decades. Even the Voyagers travelling bravely beyond the sun's reach will go silent within a century as their nuclear batteries fade. Their golden records built to outlast us will one day be worn smooth by micrometeorites, tiny grains of dust striking with the force of bullets. After 1 billion years, those proud symbols of humanity will be little more than cosmic rubble. Now imagine a vessel built not by us, but by another civilization hardened against decay. Even then entropy waits, metals corrode under radiation, circuits lose coherence, ice cracks and reforms until its structure is no longer what it was. Space is not a museum that preserves, it is a sea that erodes. Every traveller must eventually surrender. This is why most scientists dismiss the notion of seed ships as more fantasy than fact. The barriers are not just technological, they are physical, written into the laws of the universe. To survive 1 billion years, a payload would need protection beyond anything we can imagine, perhaps self-repairing materials or quantum storage of information, or some form of hibernation biology that can reset itself endlessly. These are concepts closer to science fiction than science, and yet the comparison humbles us. Our satellites orbit for decades. Our probes survive for years. The timescales we manage are the blink of an eye compared to the journeys we speculate about. To even dream of surviving cosmic time is to measure our fragility against the vastness of the universe. So while 3 Atlas as a seed ship makes for captivating imagination, the reality is harsher. The cosmos is not gentle enough to keep such secrets intact. More likely it is what the evidence suggests, a shard of ice and dust, ancient but not deliberate. Still, the dream persists, because in imagining what cannot be, we are reminded of how small and how new we truly are. The thought of 3 Atlas as a Trojan horse smuggling alien payloads into our solar system has the flavour of a late-night thriller. Science fiction has played with this idea for decades, ships disguised as comets, spores waiting millennia to bloom, silent watchers biding their time until humanity is ready or vulnerable. It makes for captivating cinema, but poor science. The limits of such paranoia are clear once we hold them against physics. As we've seen, radiation would sterilize biology over billions of years. Machines too would erode beyond recognition. The notion of a functional probe or weapon hidden inside 3 Atlas collapses under the sheer weight of time. To cling to the idea is to ignore the reality of entropy, which does not negotiate. And yet these fears resonate because they echo patterns we know from our own history. We fear invasion because humans have carried invasion in their own sails and engines. We imagine hidden payloads because we ourselves have hidden soldiers in wooden horses, missiles, in silo satellites, disguised as weather monitors. Our paranoia is not born from the stars, but from our reflection in them. In truth, if a civilization wished to invade or seed Earth, they would not send a fragile comet across billions of years, hoping it might arrive intact. They would come swiftly, deliberately, with methods beyond our comprehension. The idea of a silent invasion smuggled inside a comet is not strategy, it is story. And stories are how we process fear. So why do these stories persist? Because they give shape to the unknown. The universe is vast and silence can feel unbearable. Filling that silence with dark imaginings is easier than accepting the truth of emptiness. Fiction comforts us by giving the void a face even if it is hostile, but science demands we resist that temptation. 3 Atlas is almost certainly natural, a shard of ice and dust obeying the laws of physics, not a vessel hiding alien intent. The silent invasion makes for gripping pages and films, but when held to the light of reason it dissolves like a shadow. And perhaps that is the deeper comfort. The cosmos is strange enough without needing monsters in the dark. Its mysteries are real and they are enough. For all its strangeness, 3 Atlas gave humanity something rare, a moment of unity. When the news broke, telescopes across the globe pivoted like a choir, lifting their voices together. Chile's desert observatories, Hawaii's volcanic summits, the high plateaus of the Canary Islands, the peaks of the Andes all turned their mirrors toward a tiny point of light slipping across the dark. The coordination was seamless, almost instinctive. Astronomers who might otherwise compete for scarce telescope time shared data freely, knowing this was a chance that would not return. In South Africa, observers logged spectra through long winter nights, sending results to colleagues just waking in California. In Japan, astronomers rose before dawn to catch a final glimpse, handing the baton to teams in Hawaii, waiting under an evening sky. It was a relay across time zones, a watch that never slept. There was something profoundly human in those vigils. In Chile, a researcher wrapped in a heavy coat stepped outside between exposures, her breath fogging the thin desert air. She tilted her face toward the same stars she studied through machines. In Hawaii, technicians climbed into domes at midnight, the lava rock still warm beneath their boots, to align mirrors against the glow of galaxies. In Spain, an observer sipped bitter coffee at 3 a.m., eyes gritty, waiting for the faint smear of data that would carry halfway around the world before sunrise. Each of them knew that in isolation their work was just numbers, but together the numbers formed a picture, the picture a story. This was not only science, it was a chorus that spanned oceans and continents, languages and cultures bound together by the fleeting passage of a visitor from the stars. 3 Atlas did not care who watched it. It traced its ancient arc without pause. But for a moment, humanity cared together. Rivalries softened, politics receded, and the global community of scientists behaved as if borders did not matter. All that mattered was the rock, the question, the chance to glimpse something older than the sun itself. Perhaps that is the quiet gift of such visitors. They remind us that beneath the banners of nations, we are one species under one sky. And sometimes it takes a fragment of ice from another star to make us remember. When an object like 3 Atlas streaks into our solar system, the excitement is electric, but science demands restraint. That is where the International Astronomical Union, the IAU, steps in. Founded in 1919, the IAU is the body that brings order to cosmic discovery. It is their protocols that give new objects their names, confirm their nature, and most importantly keep extraordinary claims tethered to evidence. In the case of 3 Atlas, the process began as it always does: provisional designations, orbital calculations, independent confirmations. No single observatory is trusted alone. One telescope's finding must be checked by others' data, compared, positions triangulated. Only when multiple independent lines of evidence agree does the IAU accept a discovery as genuine. This culture of verification is more than bureaucracy, it is survival. Astronomy has endured its share of missteps. In the 19th century, astronomers swore they saw canals on Mars, long straight lines that later proved to be illusions of the eye. For decades, a phantom planet named Vulcan was said to orbit between Mercury and the Sun, invented to explain orbital quirks. It took Einstein's theory of relativity to show that Vulcan never existed. Each era humbled science, but also strengthened its defenses. The lesson was clear: trust but verify. The IAU embodies that lesson. Its meetings and circulars may seem dry compared to the thrill of discovery, but they serve a vital role, ensuring that when the world hears of an interstellar visitor, it is fact, not rumour. That discipline matters all the more in an age of instant headlines and social media storms, where a single phrase, alien probe, cosmic intruder, can ignite panic before the data has even been checked. Through self-correction, astronomy has earned its credibility. When mistakes arise, they are acknowledged and revised. When new theories challenge old ones, the stronger ideas prevail, not by persuasion but by evidence. It is a slow rhythm, less dramatic than the stories we imagine, but it is how science survives its own curiosity. 3 Atlas, with its quirks and anomalies, was carried through this process like every other object. Verified, catalogued, studied. The protocols of the IAU remind us that even when speculation runs wild, there is a framework holding the conversation steady. Without it, discovery would dissolve into myth. With it, astronomy continues to walk the narrow path between imagination and truth. The story of astronomy is filled with moments when curiosity collided with mystery, and skepticism stood in the middle demanding caution. 3 Atlas is only the latest in this lineage, joining a long line of anomalies that have tempted humanity to believe we were standing on the brink of cosmic revelation. In the summer of 1977, a radio telescope at Ohio State University detected a signal unlike any other. It lasted just 72 seconds, but was sharp, strong, and centered around the 1420 MHz frequency of neutral hydrogen, the very frequency many scientists imagined extraterrestrials might choose for communication. Astronomer Jerry Amon circled the data on the printout and scribbled a single word in the margin: "Wow." For decades, the WOW signal has stood as one of the most tantalizing mysteries in SETI, the search for extraterrestrial intelligence. And yet, despite countless follow-up observations, the signal never repeated. No one could prove what it was, an alien call or just an earthly transmission bouncing strangely across the ionosphere. Curiosity said, "Look closer." Skepticism said, "Not enough." The balance held. Oumuamua, discovered in 2017, sparked a similar clash. Its odd shape, its lack of a visible tail, and its unexplained acceleration led to a flurry of speculation. Was it a comet, unlike any we had seen before, a shard of exotic ice, or, as Avi Loeb proposed, a fragment of alien technology? For a brief moment, the world leaned toward wonder. But science, with its slower heartbeat, demanded patience. Careful studies showed that faint outgassing could explain the acceleration even without a visible coma. The extraordinary story collapsed back into the ordinary, though the questions it raised still echo. These episodes are reminders of how science survives its own temptations. An anomaly is not a revelation, it is a puzzle. Some puzzles lead to breakthroughs. Kepler's ellipses, Einstein's relativity. Others dissolve when the data sharpens. To treat every oddity as evidence of intelligence would be to abandon rigor. To dismiss every anomaly without consideration would be to abandon imagination. And so with 3 Atlas, astronomers tread the familiar path, curiosity sharpened by skepticism. The excitement is real, another interstellar visitor older than the sun full of quirks. But the restraint is just as real. For in the balance between those two lies the integrity of science, and perhaps one day the credibility we will need if the cosmos ever truly answers back. One of the quiet triumphs of modern astronomy is not just the power of its instruments, but the openness of its vision. When Hubble takes an image, when Webb records a spectrum, when NASA's archives update with new observations, those data do not remain hidden behind locked doors. They flow outward, available to the scientific community and often to the public at large. 3 Atlas, like so many discoveries of this century, was not owned by any one nation. It was studied in the open light of shared science. This transparency is striking when placed against the shadows of the past. During the Cold War, the sky was a battlefield of secrecy. Satellites were launched under false names, their purposes disguised. Data from reconnaissance telescopes were classified, locked away in government vaults. To look up was in many ways to enter a space of suspicion, where every point of light might carry hidden agendas. The heavens became not a commons, but a chessboard. How different then is the world of astronomy today. Hubble's deep fields, those dizzying portraits of thousands of galaxies, were not restricted to a privileged few. They were released for all to see, for students and citizens as much as for professors. Webb's shimmering images of distant nebulae arrived not as secrets, but as press releases lighting up phone screens as quickly as they appeared in journals. And the data that underlies them, the numbers, the spectra, the raw files sit in archives that any determined researcher can access. 3 Atlas benefited from this culture. Observatories shared their measurements. Agencies coordinated, not concealed. Images and spectral lines appeared in public databases, where independent teams could analyze them, check them, debate them. No single government could claim ownership. No corporation could lock it behind a patent. The rock was too ancient, too vast, too much a part of the cosmos itself to be hidden. This openness does not mean there are no disagreements, no rivalries. But it means that the foundation of discovery is trust that the data can be seen tested and challenged by anyone with the skill to do so. It is a quiet revolution in science, conducted not in secrecy but in daylight, and in that perhaps lies a lesson. The universe is big enough to humble us all, To hoard its wonders would be to miss their true gift. By opening the skies by letting 3 Atlas belong to everyone, astronomy reflects a rare truth that knowledge when shared multiplies. Whenever an anomaly like 3 Atlas appears, a subtle debate surfaces in the background. Should discoveries of this magnitude always be shared openly? Or are there circumstances where secrecy is justified? The question may sound academic, but it carries the weight of history and the tension of trust. Some argue for caution. If evidence ever pointed toward deliberate intelligence signals, patterns guidance, would public release be some knowledge spreads at the speed of a headline, and with it come rumors, fears, and conspiracy theories. A premature announcement could ignite panic, destabilize economies, or shake faiths. Governments might feel tempted to keep such findings classified to study in silence until the truth was secure. In their view, secrecy is not about control, but about protection. And yet secrecy carries its own danger. The Cold War showed us what happens when the skies become hidden behind veils of military necessity. Information hoarded breeds mistrust. Rumors grow faster than truth, and once trust erodes, it is almost impossible to restore. In a democratic world, withholding discoveries of cosmic importance could fracture the very societies meant to be protected. Science thrives on openness, on peer review, on the self-correcting nature of shared scrutiny. Without that, discovery becomes dogma and knowledge becomes suspicion. 3 Atlas itself is proof of another path. Observatories across nations shared their data freely. Hubble's images, Webb's spectra, NASA's archives all poured into public channels. Independent researchers could weigh the evidence, challenge assumptions, and refine conclusions. This transparency did not create chaos, it created confidence. People may still speculate, but the foundation remains solid. The data are there for all to see. There is a deeper lesson here. Science is not only about facts, it is about trust. The public does not follow every spectral line or orbital calculation, but it does watch whether scientists speak openly or retreat into shadows. When astronomers announce that an object is interstellar, we believe them not because of authority, but because of openness. And if ever a discovery were made that touched the deepest of questions, are we alone? It is hard to imagine the world accepting an answer whispered behind closed doors. So the debate continues: secrecy to prevent panic or openness to preserve trust. For now, astronomy has chosen the latter. 3 Atlas belongs to the commons of human knowledge, and perhaps that is as it should be. The stars were never ours to hoard, and the truths they reveal lose their power if hidden. The story of 3 Atlas followed a rhythm familiar to science. First astonishment, then speculation, and finally the slow settling of consensus. When it was first detected, headlines swirled with fear, an interstellar rock hurtling toward us, maybe even an alien probe in disguise. But as the data mounted, the noise began to quiet. Step by step, astronomers turned wonder into numbers. Telescopes across the globe measured its brightness, plotted its orbit, and captured its spectral fingerprints. Early anomalies, its unusual outgassing, its high velocity, its chemistry were logged and debated. Theories blossomed wildly from natural oddities to engineered relics. Yet with each passing week, the raw data grew thicker, the models more refined. Patterns emerged and possibilities narrowed. Peer review played its quiet but vital role. Preliminary papers were written and sent to journals where other experts probed them for flaws. Were the spectral lines truly as unusual as first claimed, or could calibration errors explain them? Were the accelerations real or artifacts of noisy measurements? Replication became the crucible of truth. One observatory's report meant little, until another thousands of miles away confirmed it independently. The process was often frustrating, especially for the public who wanted immediate answers. Speculation makes for captivating headlines. Peer review makes for long silences, but slowly consensus formed. 3 Atlas's speed was extraordinary, yes, but within the natural range for an interstellar comet. Its carbon dioxide-rich chemistry was unusual, but not impossible. Its outgassing at 3 astronomical units was odd, but explained by volatile ices, different from those common in our solar system. Step by step, the extraordinary collapsed back into the ordinary, not with a dramatic announcement, but with the quiet hum of data agreeing with data. This is how science guards itself against its own imagination. Fear and wonder drive the first questions, but evidence settles the answers. The path of 3 Atlas from mystery to consensus is not a failure of drama. It is the triumph of a method that prefers truth over thrill, and if one day the data refuses to bend toward natural explanation, If replication only sharpens the anomaly instead of dissolving it, then that same method will give us confidence when we say this time it's different. For now, though, the path of evidence leads us back to safety. 3 Atlas is strange, but it is not alien. And the very process of proving that has reminded us why science matters, not because it rushes to the extraordinary, but because it is patient enough to endure the ordinary until the extraordinary is undeniable. In the end, the path of 3 Atlas proved smooth, steady, and mercifully safe. Its hyperbolic trajectory, fast, clean, and untouchable, was calculated again and again, each time confirming the same truth: this visitor would not linger, and it posed no threat. It would graze the inner solar system like a stone skipping across a pond, then vanish into the dark, never to return. Astronomers spoke of its flight with the calm assurance of navigators. Its closest approach carried it nowhere near Earth's orbit. Its speed, nearly 30 kilometers per second, guaranteed that no planet could capture it, not even the gravity of the sun itself. This was no intruder circling for attack. It was a passerby, a traveller whose story intersected ours only by chance. The best metaphor is maritime. Imagine standing on a lonely shore gazing out at a vast moonlit ocean. Far on the horizon you glimpse the silhouette of a ship. It does not turn toward you, does not lower its sails, does not signal. It simply glides past steady on its own course, and within minutes the horizon swallows it again. You are left with the knowledge that it was there, that you were not alone in that moment, but the ship itself belongs to another journey beyond your reach. So it is with 3 Atlas. It arrived without warning, stirred our imagination, then slipped silently onward. A thread in a tapestry too vast for us to follow. Its harmless passage is not a disappointment, but a reminder that the universe is not conspiring against us. Most of its wonders move with indifference, neither threat nor gift, simply the quiet persistence of matter in motion. And yet even in its harmlessness, 3 Atlas leaves an imprint. For centuries we believed our solar system was self-contained, an island in the dark. Now we know better. Visitors come and go silent as ships on far seas. Most carry nothing more than ice and dust, but each one asks us to look up to wonder and to remember how vast the ocean truly is. To say that 3 Atlas may be 5 billion years old is to say something almost beyond comprehension. Numbers like that do not live easily in the human mind. A century we can imagine a grandparent's lifetime, the arc of a city changing before our eyes. 1,000 years we can stretch to cathedrals rising in Europe, dynasties ruling in China, civilizations blooming and fading. 10,000 years carries us back to the dawn of agriculture, to the first villages by rivers. 1,000,000 years already it feels abstract, the span of evolution shaping new species. But 1,000,000,000 years? That is time so vast it dissolves human scale completely. If 3 Atlas has indeed been wandering for 5 billion years, then it began its journey before Earth had continents, before oceans took their shape, before the first cell stirred in warm chemical seas. It has drifted longer than fish have swum, longer than trees have grown, longer than any living thing we know has existed. Through ages, when dinosaurs thundered across forests, through the rise and fall of ice ages, through the brief bright flicker of human civilization, it has been moving, indifferent, patient. Think of what 5 billion years means beside our history. Rome lasted 1,000 years. The pyramids of Giza are 5,000 years old. The oldest written story, the Epic of Gilgamesh, was inscribed barely 4 millennia ago. All of this, every empire, every song, every prayer, has unfolded in the blink of 3 Atlas's journey. And yet here it is intersecting our lives for a few short months. Our telescopes catch its light, our instruments record its spectra, our imaginations wrap around its mystery. Then it slips onward, carrying with it a memory older than the sun itself. To reflect on such timescales is to feel both small and strangely uplifted. Small because our lives are moment sparks in the darkness, but uplifted because those sparks are bright enough to notice, to ask, to wonder. 3 Atlas has been wandering since before there were eyes to see it, and now, for the briefest instant, it is seen. Perhaps that is its quiet gift, to remind us that time does not belong to us yet, wonder always can. If humanity worries about being watched, the truth is far more humbling. Our own signals are barely a whisper against the roar of the galaxy. For just over a century, Earth has leaked radio into space, first with the crackle of Marconi's wireless, then with television broadcasts, satellite beacons, and military radars. To us it feels like noise filling the air. But beyond our atmosphere that noise fades, almost immediately swallowed by distance. Radio waves spread like ripples on water, weakening as they travel. Within a few light years, our strongest transmissions blur into background static. By the time they reach even the nearest stars, they are so faint they drown in the hiss of cosmic radiation. A civilization 10 or 100 light years away would struggle to detect us at all unless they were deliberately listening with its instruments beyond anything we can build. And the galaxy itself is immense, 100,000 light years across with hundreds of billions of stars. Against that scale, a century of radio is a pinprick of light in a canyon of shadow. If another world did notice us, it would likely be because they were already looking closely, not because we shouted loud enough. This is why astronomers remind us Earth has not truly announced itself. Our presence is local, fragile, easy to miss. If civilizations exist, they may not yet know we are here, and if they do, it is because they chose to see the faintest of flickers. 3 Atlas drifting across our skies sharpens that contrast. We imagine it as a watcher, perhaps an emissary, but in truth, we are the quiet ones. We are the young civilization still learning how to speak our signals, barely reaching beyond our neighborhood. The silence of the stars is not necessarily absence, it may simply be that we have not yet learned how to listen loudly enough or long enough. So when we wonder whether 3 Atlas noticed us, the irony is clear. Our century of radio chatter is a child's murmur compared to the deep quiet of cosmic time. The galaxy does not tremble at our noise. It barely hears us at all. If Oumuamua, Borisov, and now 3 Atlas have taught us anything, it is this: we have barely scratched the surface of what drifts between the stars. 3 visitors in less than a decade suggest the galaxy may be rich with wanderers, each a messenger of conditions far beyond our sun's nursery. And if that is true, then what we have seen so far may be the tamest of the lot. Imagine the surveys of the future when telescopes like the Vera C, Rubin Observatory in Chile sweep the skies every night, cataloguing millions of faint streaks. Among them will be more interstellar travelers, each with its own chemistry, its own history. Some may resemble comets, familiar in shape but alien in composition. Others may defy our categories entirely. Perhaps one day we will find a comet made not of water ice but of methane and ammonia glowing blue-green in the light of the sun, or a fragment of a shattered planet, its surface rich in metals, an interstellar shard of nickel and iron glinting like a blade. Some have speculated on the existence of diamond worlds born under crushing pressures, their fragments drifting as crystalline comets that sparkle with impossible brilliance. Others may be rogue icebergs the size of mountains, carrying exotic ices we have never seen on Earth, frozen nitrogen, or even elements that evaporate before they can be studied here. And then there are the true outliers we can only imagine. What if a visitor arrives blacker than coal, absorbing nearly all light invisible to ordinary telescopes? What if one comes spinning so fast it fractures before our eyes, scattering fragments across the sky? What if we find one glowing faintly not from sunlight but from radioactive decay, deep within an ember from a dead star's furnace? Each discovery will stretch our sense of the possible. Already the first 3 visitors have done so. Oumuamua with its eerie shape and unexplained acceleration, Borisov a textbook comet but born under another sun, and 3 Atlas older than Earth stirring with strange chemistry far from warmth. These are just the opening notes of a symphony we have not yet heard. The unknown variety waiting in the dark reminds us that interstellar space is not empty. It is a drifting archive of experiments, failures and wonders. Every object is a survivor of ancient chaos, a fragment of stories we will never fully know. The thrill lies in this, that the next time we look up the sky may already be holding something stranger than fiction waiting for us to notice. In the first hours after 3 Atlas was spotted, the headlines brimmed with alarm. An interstellar object moving faster than anything we had seen on a trajectory through the heart of the solar system. How could it not ignite fear? The unknown always sharpens our anxieties. For a moment it was easy to imagine worst-case scenarios, a collision, a hidden payload, a silent invasion. But fear faded as maps took shape. Within days, astronomers had charted its hyperbolic course with precision. The calculations were run and rerun telescopes across continents contributing data until the conclusion was undeniable. 3 Atlas would not strike Earth nor any planet. Its path was safe, clean, predictable. The panic softened into curiosity. This shift is deeply human. Again and again we fear first and understand later. When Halley's comet flared across the skies in 1910, people sealed their windows in dread of its poisonous tail. When solar eclipses darkened the midday sky in ancient times, villages erupted in terror, fearing dragons or gods. Yet each time knowledge dissolved, the fear replacing it with the wonder. The dragon became the moon, the poisoned tail became cosmic ice, the imagined danger faded into awe. 3 Atlas followed the same arc. What began as a story of menace ended as a story of marvel. Once its orbit was mapped, it was no longer a threat, it was a gift, a visitor offering us a glimpse of a galaxy-wide journey. The very act of measurement transformed chaos into calm, uncertainty into discovery. There is a lesson in this rhythm. The unknown provokes fear because it strips us of control. But the act of understanding, of mapping, naming, studying returns that control even when the truth is still vast and humbling. Fear is our reflex, wonder is our reward. And so by the time 3 Atlas slipped deeper into the night sky, the fear had vanished. What remained was a quieter emotion, gratitude that we had seen it at all. Once 3 Atlas's trajectory was secured and the panic began to ebb, another challenge emerged: how to speak about it to the world. The data alone was not enough. The public needed context, reassurance, and above all trust. Institutions like NASA, the European Space Agency, and national observatories took up the task. Press briefings became the stage. Astronomers stood before cameras, translating orbital diagrams into plain language. It will not hit us. It cannot be captured. It is simply passing through. They showed animations of the comet's path, bright arcs against the black to make the math visible. Journalists asked about aliens, about impact risks, about whether governments were hiding something. Each time the scientists responded patiently, reminding everyone that evidence matters more than speculation. This openness mattered. In an age when misinformation spreads faster than truth, silence breeds suspicion. By speaking plainly and often, institutions prevented fear from filling the vacuum. They shared Hubble and Webb images, freely published spectra online, invited amateurs to contribute their own observations. It was not only a scientific project, it became a communal one. Trust in science is fragile, built slowly, and broken quickly. For many, the 3 Atlas story was a small test of that trust. Would scientists tell us everything? Would they downplay risks? Or would they speak candidly, even when the answer was simply, "We don't know yet"? In choosing transparency, astronomy reaffirmed its credibility. And beyond reassurance, the communication carried inspiration. Press releases did not just emphasize safety, they emphasized wonder. They reminded the public that this object was older than the sun, that it had traveled for billions of years to brush against our gaze. In that framing, fear gave way to awe. The result was a narrative shift from cosmic intruder to cosmic guest. The same telescopes that measured its orbit also gave us poetry in their images, wisps of a coma against starlight, a fleeting reminder of the galaxy's immensity. And because those images were shared openly, they belonged not just to scientists, but to anyone who looked up and wondered. 3 Atlas taught us many things about chemistry, physics, and celestial motion. But it also taught us something about ourselves, that knowledge spoken with honesty has the power to steady fear and kindle curiosity, and in a world often divided by doubt, that may be its greatest gift. The story of 3 Atlas is not only about a comet from another star, it is also about the way humanity met it with instruments, imagination, and patience. In its first days, speculation ran wild. Could it be a probe, a seed ship at a hidden Dendia? The questions were natural, even necessary, but what mattered most was how they were answered, through the steady rhythm of science. Step by step, evidence replaced rumour. Telescopes gathered data, astronomers checked and rechecked, independent teams replicated results. Peer review sharpened the claims, trimming away exaggeration, leaving behind what the numbers could truly support. Imagination was never discarded. Scientists still allowed themselves to wonder, to ask what if, but imagination was always tethered to fact. This marriage of curiosity and caution is the very heart of the scientific method. Without imagination, we would never ask bold questions. Without discipline, we would never trust the answers. 3 Atlas gave us both. It invited wild speculation and then reminded us that careful measurement is the only compass we have in the dark. And in the end, that compass worked. What began as a story of potential menace became a lesson in natural wonder. 3 Atlas was extraordinary, yes, but not because it was artificial. It was extraordinary because it was real, a shard of another system older than our sun brushing against us by chance. The triumph lies not in proving alien contact, but in proving that our methods are strong enough to separate dream from truth. Perhaps that is the quiet miracle here. Humanity has always lived in the tension between myth and knowledge, between fear of the unknown and the courage to understand it. In 3 Atlas we saw both sides, but the method held firm, carrying us from confusion to clarity without breaking. Science does not silence wonder, it protects it. By showing us what 3 Atlas truly is, evidence kept or intact but grounded. And that balance, fragile yet resilient, is why we will be ready when the cosmos presents us with the next riddle, whether comet signal or something stranger still. When astronomers turned their instruments toward 3 Atlas, one chemical signature kept appearing louder than expected: carbon dioxide. Most comets in our solar system are dominated by water ice with CO2 and carbon monoxide playing smaller supporting roles. But 3 Atlas seemed to be different, rich in carbon-based volatiles, its breath carrying a chemical accent from another star. This matters because comets are more than icy wanderers, they are time capsules. Each one preserves in its frozen crust the conditions of the nursery where it was born. In our solar system, some comets formed near Jupiter and Saturn, where water ice was abundant, while others formed farther out where more exotic ices could survive. Their chemistry is a fingerprint of their birthplace. 3 Atlas then is not just a visitor, it is a clue. Its carbon-rich composition suggests that in its original system conditions favoured the freezing of CO2. Perhaps its parent star was smaller and cooler, shifting the ice lines inward. Perhaps it formed in a region dense with carbon compounds, unlike the balance we see at home. Whatever the case, its chemistry reminds us that the diversity of comets across the galaxy must be immense. Imagine the possibilities. Some systems may spawn comets laced with methane, others with ammonia, others still with exotic ices we can barely imagine, neon, argon, even nitrogen in crystalline sheets. Each system writes its own recipe, and each comet that drifts free becomes a messenger carrying that recipe across the stars. Carbon in particular captures the imagination because it is the backbone of life as we know it. To find a comet rich in CO2 is not to find life, but it is to glimpse one of life's essential ingredients locked in ice and flung across space. If 3 Atlas carries carbon outward from its home, then so might countless others, scattering the raw materials of biology like seas on galactic winds. This is the gift of chemistry. It tells us that we are not isolated. Our solar system is not unique, but one experiment among billions. And every time an interstellar visitor reveals its chemical soul, we learn a little more about how wide and varied the experiments of the universe truly are. 3 Atlas, with its carbon signature, adds another line to that story. It is not just a comet, it is a reminder that the galaxy itself is a laboratory, and that life's building blocks may be far more common and far more widely shared than we once dared to believe. One of the quiet revolutions of our age is that discoveries no longer belong only to those who make them. When Hubble or Webb turns its gaze toward the sky, the images do not vanish into classified drawers or hidden servers. They flow outward into archives, open, accessible, waiting for anyone curious enough to look. 3 Atlas was no exception. Within days of its observation, data began appearing in NASA's repositories curated by the Space Telescope Science Institute. Their alongside spectra and orbital plots were the images, faint smears of light, subtle halos, the barely perceptible whisper of a visitor from beyond the sun. Scientists studied them with care, but so did students, hobbyists and dreamers. Millions of eyes peered at the same data from their own glowing screens. Imagine the scene in a bedroom in Tokyo. A teenager zooms in on the Webb image, marveling at how something so small could be so ancient. In a cafe in Buenos Aires, a retired engineer scrolls through Hubble data, remembering the Apollo broadcasts of his youth. In Nairobi, a group of university students debate what the spectral lines might mean, cross-referencing with notes in textbooks. Around the world, strangers are united by the same fragment of light, the same question: what is this thing? This is the true magic of open archives. They democratize wonder. They allow a farmer, a poet, a child with no telescope to stand shoulder to shoulder with astronomers looking at the very same images, touching the very same mystery. Unlike the Cold War skies shrouded in secrecy, today's heavens are shared. The files that chart 3 Atlas's path are not locked in vaults. They are given freely, as if to say this belongs to all of us. In an era of fractured trust and divided voices, that gesture carries weight. It reminds us that curiosity is not limited by geography, wealth, or training. The archives are a library, written in starlight, open to anyone who wishes to borrow a page. And so when 3 Atlas fades back into the darkness, what remains are not only the measurements in professional papers, but also the echoes of millions who gazed at its image online and felt, if only for a heartbeat, that they too had glimpsed something vast. That is not just science, It is shared humanity preserved in the archives of wonder. Night after night, the glow of 3 Atlas dimmed. What began as a curious streak visible in telescopes from Chile to Hawaii slowly surrendered to distance. The coma thinned, the tail once a faint veil against the stars dissolved into invisibility. And then, like an actor bowing after the final line, it slipped beyond the reach of even our sharpest instruments. The cosmic curtain fell. It felt almost theatrical the way this object had burst onto our stage with questions and speculation, captured the world's imagination, and then departed, leaving us to ponder what it meant. For months it had been the centerpiece of our vigil. Then, without ceremony, the show was over. Astronomers compared their last images with the first, astonished at how quickly it had faded. What had been a beacon from another star system became once again what it had always been, a piece of dust and ice indistinguishable from the darkness. The galaxy swallowed it without effort, as if to remind us that even wonders are temporary. The metaphor is irresistible. 3 Atlas was like a traveller pausing at our window for a brief hello before walking back into the night, or like a lantern glimpsed through fog gone before you can decide if it was real. Its departure was not violent, not dramatic, but gentle, a reminder that the cosmos writes in slow, quiet gestures rather than sudden endings. Curtains close, but they also invite us to wait for the next performance. Already telescopes are preparing to catch the next interstellar wanderer. Perhaps it will be stranger. Perhaps it will be ordinary. Either way, the stage will open again and humanity will look up with the same anticipation. As 3 Atlas faded into obscurity, it left behind no clear answers, only memories and data. But in that vanishing act lay the real gift, the reminder that the universe is not static, not silent, but alive with travellers. We are not the only story being written under the stars. As 3 Atlas receded into the dark, it left us not with terror nor with proof of alien machines, but with something far older and more enduring humility. To glimpse a fragment older than our sun passing through without notice or intention is to be reminded of our scale. We are brief, fragile, a species barely a breath long against the endless tide of time. Philosophers have long wrestled with this truth. The Stoics of ancient Rome urged their students to look at the night sky and remember that human quarrels are small beside the turning of the heavens. The Taoists spoke of flowing with the great order of things, surrendering ego to the rhythm of the cosmos. Even the Psalms sung under desert stars ask, "What is man that thou art mindful of him?" Across cultures, across millennia, the stars have been the measure of humility. 3. Atlas sharpens that lesson. Its journey of billions of years dwarfs our civilizations, our empires, even our species. The pyramids are young beside it. Rome is young. The very continents shifting and colliding are young. Against that timescale, our triumphs and failures alike are brief sparks in the dark. Yet humility need not be despair. To be small does not mean to be meaningless. A single flame is small, yet it lights the room. A single human life is short, yet it can carry kindness, invention, love. Our insignificance in size and time is balanced by our capacity for awareness. We are creatures who can know our own smallness, and in that knowledge lies a kind of greatness. 3 Atlas asks nothing of us. It does not care that we watched or wondered, but we care, and in that caring, in that reflection, we are changed. To look at it and see humility is to stand in the same tradition as sages, poets and dreamers who gazed upward before us. It is to remember that awe is not weakness, it is wisdom. 3 Atlas. 3 Atlas showed us something deeper than ice and gas. It revealed the twin ways humans make sense of the unknown. On one side is science patient and methodical, sifting spectra and plotting orbits. On the other side is storytelling, our instinct to spin meaning from mystery, to imagine hidden probes, seed ships, or cosmic messages. We need both. Speculation without skepticism leads to myth unchecked. Skepticism without speculation leads to silence, to questions never asked. Together they form a balance that has guided us since the first humans stared at the stars. The myths of ancient Greece, where comets were seen as omens of the gods, were not science, but they were stories that helped people situate themselves in a vast, unsettling cosmos. In medieval Europe, celestial events were woven into prophecy. In modern times, science fiction has taken up that mantle, imagining alien craft disguised as asteroids or messages buried in starlight. These cultural echoes do more than entertain. They stretch our minds toward possibilities science has not yet proven. Jules Verne wrote of submarines and spaceflight before either existed. Mary Shelley imagined biotechnological creation long before genetic engineering. In the same way, our speculations about objects like 3 Atlas, though unproven, prepare us to see what might otherwise be overlooked. Philosophy too plays a role. From Aristotle to Kant to contemporary thinkers, philosophy has asked not just what is there, but what does it mean that it is there? When we speculate about 3 Atlas as a relic or a probe, we are really wrestling with questions about ourselves. What it means to be intelligent, what it means to endure, what it means to be one among many rather than the solitary spark in a silent universe. Science and storytelling are not enemies, they are companions. Science tells us what we can trust today, storytelling reminds us what we might discover tomorrow. Without science, we would still believe comets were curses. Without storytelling, we would never dare to imagine life beyond our planet. 3 Atlas. In its brief passage, invited us to hold both at once the rigour of evidence and the wildness of wonder. Part 49, The Great Human Question. As 3 Atlas fades into the dark, what remains is not only data, but a mirror. For in every speculation we cast upon it, probe or comet threat or messenger, we were really speaking about ourselves. The object was indifferent. The stories were ours. What do these stories reveal? They reveal our fears that we might be small, fragile, vulnerable in a universe that will not pause for us. They reveal our hopes that we might not be alone, that another intelligence has crossed the same thresholds and left behind proof of survival. And they reveal our ambitions that one day we too might send our creations into the void to wander long after we are gone. 3 Atlas is not just a comet, it is a canvas. On it we project our anxieties about extinction, our longing for connection, our pride in discovery. To call it a probe is to confess our desire to be noticed. To call it a seed ship is to admit our wish that life is not confined to Earth. To call it natural is to remind ourselves that mystery can exist without intention, that the cosmos is already vast enough to inspire awe without adding our fears. This is the great human question, not what 3 Atlas is, but what it makes us see about who we are. Are we a species defined by paranoia looking for threats in every shadow, by curiosity chasing meaning in every anomaly, or by wonder content to marvel even when the truth is simple? Perhaps we are all 3, and that is why objects like this capture us so completely. The comet passes, the calculations settle, the panic fades, but the questions endure because they are not about the rock at all. They are about the travellers who looked up, asked, and for a brief moment felt themselves reflected in something older than time. When 3 Atlas slipped past our telescopes, it left behind more than chemical traces and orbital curves. It left us staring once again at the silence above. For all the speculation of probes and signals, for all the whispers of alien craft, the truth is that the sky remains mute. No clear message, no undeniable beacon, no sign that someone else is looking back. This silence is the heart of the Fermi paradox. Statistically, the galaxy should be alive with voices. Hundreds of billions of stars, many with planets, many of those in habitable zones. Life should not be rare, intelligence should not be unique, and yet across the decades of listening we hear only the hiss of background static. The silence unsettles because it forces us into uncomfortable possibilities. Perhaps we are early the first sparks in a galaxy still waking. Perhaps civilizations flare and die so quickly that their voices never overlap. Perhaps they choose quiet, wary of attracting predators in a dark forest. Or perhaps the filter lies ahead waiting for us, ensuring that no civilization lasts long enough to shout across the stars. 3 Atlas brushes against these questions because it was the kind of thing we wanted to be a message. A visitor, a relic, a sign that silence is an illusion. Instead, it reminded us that most of what drifts between stars is indifferent matter. The silence remains. And yet silence is not emptiness. It is an invitation. The universe has not told us no, it has only withheld a yes. In that space, we are free to wonder, to search, to hope. Silence forces us to keep asking, to keep listening, to keep sending our own faint signals outward. Perhaps one day the sky will answer. Until then, the silence is ours to contemplate. It is not a verdict, but a mystery one that makes us look up again and again, even when the night is quiet. Speculating on 3 Atlas as a probe invites a stranger, deeper question. What would we look like if someone else were watching us? If an alien civilization sent its instruments drifting past Earth? What story would they tell about us from the outside, from afar? They might first see the blue and white shimmer of our planet, a jewel of oceans wrapped in clouds. They would note the thinness of the atmosphere fragile against the void. They might detect oxygen and methane in curious balance, a sign of chemistry too restless to be explained by rocks and water alone. Already they might whisper to themselves life. But as they drew closer, their sensors would register stranger signatures. A sharp rise in carbon dioxide over mere centuries, a planetary fever unprecedented in its speed. Bursts of radio waves leaking into space, growing loud for a century, then scattering into digital silence. Nighttime glows across continents, patterns of electricity sparking into being. They would see order and chaos mixed together, the fingerprint of a species capable of shaping a world but not yet of mastering itself. And what would they conclude? Would they see us as a young civilization, brilliant but precarious, like a child running with fire? Would they mark Earth as a place of promise or of danger? Would they wonder if we had the wisdom to outlast our own inventions, or if we would vanish as silently as we appeared? This thought experiment reveals why we are so fascinated by objects like 3 Atlas. We project onto it what we hope and fear about ourselves. If it were a probe, it would mean someone else survived long enough to send it a message that endurance is possible. But it would also raise the unsettling mirror, and what of us? Will we survive long enough to send our own 3 Atlas is in all likelihood a natural traveller. Yet in treating it as a mirror, we glimpse truths about ourselves that no data can measure. We are the ones desperate to be seen, the ones straining to prove that our brief spark matters in the dark. Perhaps the real probe is not out there at all. Perhaps it is our own imagination testing what kind of story we are writing on this small blue world. Step back far enough and the whole story of Earth becomes a scene in a play that has been running for billions of years. The stage is vast, the Milky Way itself, with its spiraling arms of stars, its restless migrations, its slow galactic dance with Andromeda. Upon that star, every comet, every world, every species is a character, however fleeting. 3 Atlas is one such character wandering across the boards for only a brief entrance before vanishing behind the curtain again. In contrast, our human epochs are the shortest of acts. The pyramids, grand as they are, rose barely 400-500 years ago, a blink in cosmic time. Rome's 1,000-year rule would not even count as a pause between lines. The entire history of written language fits into a single second when compared to the 5-billion-year journey of a rock like 3 Atlas. And yet here we are, an audience capable of noticing. Our species has been on this stage for only 300,000 years, but in that instant we have lifted our gaze, invented telescopes, sent machines beyond our cradle, and dared to wonder what roles others might be playing. We are both spectators and actors, speaking our lines into the void, hoping they will be heard. 3 Atlas reminds us that the cosmic stage is already full of dramas we will never witness. In stars being born, worlds colliding, civilizations perhaps rising and falling light years away. Against such a backdrop, our wars and empires shrink to whispers. But the play is not about size alone. Even a single fragile line of dialogue, our questions, our wonder adds to the script. Perhaps that is the meaning of these fleeting visitors. They give us perspective. They remind us that our story is part of something vaster, older, more intricate than we can grasp. And in that realization lies both humility and hope. We may be a small act in a grand performance, but we are an act that knows it is on the stage, and that awareness makes us luminous. 3 Atlas is not the test. We are. The rock itself moves indifferently through space, a fragment of ancient time, with no stake in our fears or hopes. What matters is how we respond to its presence, how we interpret its strangeness, and what kind of species we reveal ourselves to be in the process. Do we choose paranoia? That path is tempting. The unknown has always triggered our deepest anxieties. A flicker in the sky becomes an omen. A shadow in the forest becomes a predator. In the same way, 3 Atlas can become whatever fear we project upon it, a hidden weapon, a cosmic spy, a Trojan horse from the stars. That choice would define us as a civilization still trapped by its own terrors, unable to look beyond survival instincts. Or do we choose curiosity, to see 3 Atlas not as a threat but as a gift, a messenger of deep time, a natural relic carrying the chemistry of another star? Curiosity asks not, what danger is this, but what can we learn? It opens doors instead of slamming them shut. It defines us not by suspicion but by wonder, by our willingness to expand knowledge even when answers are slow to arrive. This is the real test of wisdom, how we balance fear and imagination. Too much fear and we stop listening, stop exploring, stop trusting. Too much imagination without discipline, and we fall into fantasy chasing ghosts where none exist. Wisdom lives in the narrow space between the courage to wonder and the humility to measure. 3 Atlas offered us that choice, and in many ways we rose to it. Scientists resisted panic, spoke openly, and treated speculation with discipline. The public, after the first wave of alarm, leaned into awe. If there is a lesson here, it is that we are capable of responding with grace. And so the test continues. Each interstellar visitor, each anomaly, each whisper from the stars will ask the same question of us. Will we shrink into paranoia or grow into curiosity? The answer will say more about humanity than about the cosmos itself. 3. Atlas, like every cosmic mystery, offers us more than data. It offers us a chance to come together. For a moment, nations set aside their differences. Telescopes in Chile, Hawaii, Spain and South Africa watched the same faint smudge of light, and their findings were woven into one shared narrative. No border could claim it, no government could own it. The comet belonged to everyone under the sky. History shows us how powerful such moments can be. In CERN, the Apollo 11 landing was not just an American triumph, it was a human one. People crowded around televisions in Moscow, in Nairobi, and Buenos Aires, watching as footprints pressed into lunar dust. The first words spoken from the moon echoed across every continent, binding billions in a single instant of wonder. The space race may have been born from rivalry, but its culmination became a shared milestone in human history. The same spirit lives on in cooperation today. The International Space Station orbits above us, built not by one nation but by many a laboratory where former adversaries work side by side. Telescopes like Webb are the fruit of partnerships spanning oceans, pooling expertise and resources to build what no single country could achieve alone. Even the search for life beyond Earth, through SETI, through planetary probes, through interstellar surveys, depends on collaboration across cultures and languages. 3 Atlas arrived at a time when our world, fractured by politics and crises, needed such reminders. Its passage was a quiet invitation to look beyond our divisions, to remember that beneath all flags we share the same fragile planet, the same sky. The cosmos is vast enough to humble us all, but also to unite us in humility. Perhaps that is the deeper meaning of these interstellar visitors. They come not to threaten or to teach, but to remind us that the Earth is small, that we are one species, and that the great questions, are we alone? How long can we endure? What legacy will we leave belong to all of us together? If we accept that call, then every comet, every probe, every whisper from the stars becomes more than science. It becomes a bond, a thread of unity stretched across the globe, strong enough to hold us together in wonder. Lessons from a visitor among the stars. When the interstellar object known as 3 Atlas passed through our solar system, it carried no message, no deliberate sign of intelligence. And yet its silent arc across the night sky offered lessons that reach far beyond astronomy. In watching it, we were reminded not only of the vastness of the cosmos, but also of the values we need to endure here on Earth. The first lesson is humility. 3 Atlas may have travelled for 5 billion years longer than Earth has existed. Against that timescale, our civilizations, our histories, even our lifespans shrink to flashes of light. Humility does not mean insignificance, though. It means recognizing that our place is small but precious, and that awareness itself is a form of greatness. To know that we are fleeting is to treasure the moments we have. The 7th lesson is the balance between curiosity and caution. At first, speculation swirled, was this an alien probe, a seed ship, a hidden threat? But science showed its strength by resisting panic testing every claim and letting evidence guide the story. This pattern applies to daily life as well. We need imagination to ask bold questions, but also patience to weigh them carefully. Wonder unmoored from discipline drifts into fear. Discipline without wonder becomes sterile. Together they form wisdom. The 3rd lesson is about fear itself. Humanity's first reaction to the unknown is often alarm. Whether it was Halley's comet in 1910, the WOW signal in 1977, or 3 Atlas in 2025. But when knowledge grows, fear dissolves into awe. The comet did not strike us, did not hide alien payloads, did not rewrite physics. Instead, it reminded us that the unknown often feels dangerous until it is understood. In our personal lives, too, uncertainty often breeds fear. But patient study and openness can transform that fear into growth. 4th 3 Atlas showed us the power of unity. Telescopes across continents tracked its path. Scientists shared data, openly archives filled with images accessible to anyone with curiosity. For a time, borders and rivalries faded. What mattered was the shared wonder of discovery. The same principle holds true on Earth's smaller scales. Cooperation magnifies strength while secrecy and division weaken us. Whether in global challenges like climate change or in simple acts of community, our best work emerges when we act as one. Finally, 3 Atlas reminded us of legacy. If another civilization ever built a probe that survived billions of years, it would be evidence not only of technology but of wisdom. Wisdom to endure, to master self-destruction, to persist across ages. Our own survival depends on learning that lesson here and now. The threats we face where environmental collapse division are our filters. Passing through them is not guaranteed. But if we endure, if we act with foresight and compassion, then perhaps one day we too will send artifacts into the galaxy, carrying the story of Earth into the long night. In the end, 3 Atlas was a natural traveller, not an alien messenger. Yet in its passage it held up a mirror. It asked us, will we meet the unknown with paranoia or curiosity, with division or unity, with short-sightedness or endurance? The choice defines not the comet but us. Thanks for being here. Hit that subscribe button and join us for the next chapters full of history and discovery.